Hey everyone, welcome. Can you see me? Am I perfectly live? Quickly let me know. Can you see me? Can you see me? Am I visible? Am I audible, everybody? Very quick. You are perfectly audible and visible. Yes. Guys, today is a fantastic session. We are live, absolutely live, and I will be shooting at you some brilliant questions from all across algebra. And trust me, you're going to love it. You are going to love it. You already know कि calculus and algebra, both of them acquire lion's share in the paper. The share that both calculus and algebra acquire in the paper is massive, it's huge, it's drastically big. Around 8 to 9 questions from calculus and around similar weightage of algebra in the paper. Not a joke. Not a joke. And the problem with algebra questions is that yes, they are calculation heavy. Yes, they are time consuming. And yes, they are a bit tricky. But when I say a bit tricky, it also brings in the space for some shortcuts, for some real smart time saving hacks. And that is what along the way I will be teaching you in today's session. All right. So everybody, can you see me, hear me clearly? Everything is perfectly audible and visible, right? Give me a quick good to go. We are going to dive into our beautiful discussion today based upon algebra questions. As I told you, it's going to be all about algebra. Today is algebra party in our class. We have what on the table? Quadratic, complex, PNC, prob, binomial, sequence series, everything is there which falls under the umbrella of algebra along with matrices and determinants. So everybody, are we all set? Good evening, Bharat. Good evening. Quickly share the session with all your friends and don't forget to mark your attendance, which is by hitting the like button. Is that making sense? Is that making sense? Everybody quickly tell me, are we excited and how is your preparation according to you when it comes to algebra? How is your preparation according to you when it comes to algebra? Which chapters you think are your strongest areas? Which chapters you think are somewhere that you fall weak behind? Tell me. Tell me quickly tell me what are the chapters which you feel are strong for you? Which are the chapters you feel are some of the weak areas for you? Quick everyone. We have MND, which I feel is pretty easy to master. And most of y'all must have mastered that topic. We have sequences series. We have binomial theorem. We have quadratic, favorite of every student. We have PNC, we have prob. Everybody please tell me. And we also have complex. Quick. Is everybody all set with the basics of all these chapters at least? Yes ma'am, no ma'am. Yes ma'am, no ma'am. Because today we are going to be diving into some really relevant and high weightage questions from all across these chapters. And this is a session which will give you an exam oriented preparation. We are very close to our JEE Main 2025 January attempt. Very close. Just a couple of weeks away and it feels like it's almost here. And this is when you need to do a very strategic, a very systematic practice. A practice which is like nail on the head practice. Means it's the perfect type of practice with the perfect set of questions which will actually make you perfectly exam ready for attacking your mathematics section in the paper. And this is exactly the type of practice which you will find in my sessions. Every question which I will share today, I have tried to make it as multi-conceptual as possible. Of course, it involves PYQs of both mains and advanced, but some questions are such that I have made them a combination of 2-3 PYQs. So that through one question, you get an access to multiple concepts. Through one question, you get access to 3-4 questions. Through one question, you get access to a lot of revision. And that is why I call my sessions a very rich practice session. Everybody, you have to take this as a challenge. Take this entire session as a challenge and see how many questions you can crack by yourself. Also check the approach. Please keep checking the approach. There is one approach which you will follow. There might be another approach which I follow. And you have to see which one is more time efficient, which one is more time saving, which one is more smart. And hence that is going to be a big learning takeaway for you. All right. Hi, Chandra. Yes, I will be doing very different, very new, very beautiful questions. I am vouching, and this is a promise that these are not the regular, dry, very common questions which you have practiced till now. Of course, the concepts that we have to target, The highest weightage concepts, most important concepts will be targeted in today's session, but the questions which I have for you, the bank of questions that I will share with you is very rich, it's beautiful, the quality is top notch. So grab your pens and notebooks, very quickly share the session with all your friends, and I want your full attention, full focus, no distraction whatsoever. Let's dive into the first question, everyone. Absolutely ready? Great job done. Then first question on your screen, guys. First question on your screen. Make sure you not just attempt it, you crack it in the first round. This is a round 1 question based upon finding remainder. You know this question is belonging to the chapter of binomial theorem. Yes, ma'am. But we are not going to open the entire expansion. No. We're going to use our shortcut. What is the name of the shortcut whenever you wish to find the remainder? The shortcut says the go, went, gone method. This is the go, went, gone method. Anyone? Anyone? Quickly tell me. I will be giving you a few seconds to crack this question. At least for this question, I believe you can crack it very quickly. Superbly quickly. You have to see what is the remainder when this giant expression is divided by 5. Is the remainder 2, 4, 3 or 0? Look at the expression. It's 2017 to the power 2018 plus 2018 to the power 2019 plus 2019 to the power 2020. Please tell me, what will you do? What is the hack to crack such questions? Always try to learn the approach. Whenever you used to find the remainder, you always have to write the base as multiple of 5 plus minus 1. The target always is to try and write the base as multiple of 5 plus and minus 1 or plus and minus 2 plus and minus a very small number. Yes? Yes, Chandra, then tell me. No, hi Naman. That is true binomial. But how will you reduce 2017? 2017 is 2015 plus 2, right? 2015 is a multiple of 5. So I can write it as 5 into something plus 2. I don't care what this k is, but it's a multiple of 5 plus 2 for sure. 2018 is 2015 plus 3. Yes, 2015 plus 3. Again 5 into k plus 3 to the power 2019. And what about 2019? This is again 5 into k plus 4 raised to the power 2020. Yes, ma'am? No, ma'am? All cool till here? Now comes the go, went, gone method. Whatever is 5 or a multiple of 5 is going to just go, went, gone. Bye, 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 bye. What are you left with? Equivalent expression is 2 to the power 2018, 3 to the power 2019, 4 to the power 2020. You must realize whatever is the remainder when you divide this expression by 5, same is the remainder when you divide this equivalent expression by 5. There is no difference. And this expression any day is easier and more manageable. Yes, because of the go, went, gone method. Answer Sharan is saying is 1. Anybody else who's got the answer? Only Sharan has got the answer. Anybody else? Very quickly. Again, now base is 2, base is 3, base is 4. I want to make the base what? In terms of multiple of 5 plus minus 1 or plus minus 2, whatever, how much ever small possible. So this looks like what? 2 square. Yes or no? 1009. 2 square means 4. What about 3? 3 to the power 2019. I know 9 is closer to 10. And 10 is a multiple of 5. I can write 3 square, which is 9, as 10 minus 1. Perfect, perfect. But there is 1 3 extra. So I will write 3 into 3 to the power 2018. 3 to the power 2018 is what? This is 3 square to the power 1009. And 3 square is nothing but 9. Perfect. What about this? This is 4 to the power 2020. As it is, I am not disturbing this at all. Why? Because now I have 5 minus 1 to the power 1009. 3 as it is. This is 10 minus 1 raised to the power 1009. And this is 5 minus 1 raised to the power 2020. Anyone who doesn't know how to crack these questions, learn it through this question. Now you can see how smartly I have converted my base into multiple of 5 plus minus 1. Yes, see, this is go, went, gone, go, went, gone, go, went, gone. I am left with minus 1 to the power an odd number, which is minus 1, plus 3 times again minus 1, plus 1. You're left with minus 4 plus 1, which is minus 3. You never ever report a negative number as your remainder. So what is your answer? What is your answer? Sai is also saying 1. Your answer is not minus 3. Your answer is what? Minus 3 plus the divisor, which is 2, bache. It's not 1. It's 2. It's not 1. Come on, people. Very simple first question. This is like a 1-minute question. Of course, I took time because I was explaining every step. How am I moving from one to the other, from then to the other? But this is a 1-minute question, guys. Very easy, very, very easy win. This is one of the easiest wins which you will get in the paper, which is finding remainder using the shortcut of go, went, gone method. Is this question clear? 1 is not the answer, guys. 2 is the answer. Is this question absolutely clear? Hashtag HDCC, everyone. Hashtag HDCC. Quickly tell me, is this question completely clear? Always remember, you have to express the base as multiple of 5 plus minus as small a number as possible. Most favorable situation is plus minus 1. Because then you just have to evaluate 1 to the power anything, which is the easiest calculation. At max, you can have multiple of 5 plus minus 2 plus minus 3 plus minus 4, which increases one more step because now you have to write again the base as multiple of 5 plus minus 1 and so on. But try to remember the hack. The hack or the shortcut says write the base as multiple of 5 plus minus 1. Is that making sense? Silly mistake? Not allowed to commit it again. Not allowed to commit it again. Is this clear? First question, hashtag HDCC, everybody. Very important, high weightage question based upon finding remainder. Must do for getting exam ready. This will come in the paper. Next question, people, take a look. Fantastic question. I challenge you to crack this. This is a 99 percentile question. Crack this. It's a fantastic question. Fantastic question. Beautiful question this is. I won't say it's very challenging or very lengthy. No. It's not very lengthy. It might look like I have to solve a series and it might take ages for me to reach the answer. It might take tons of steps for me to solve and get the answer. But actually, it's not difficult. No, it's not. Tell me. Sum of this series up to 20 terms is what? Anybody, any clue? Just keep looking at the series. It's a very smart series. Very, very smart series and very difficult for you to catch hold of the pattern. It says 8 factorial plus 9 factorial upon 2 factorial plus 10 factorial upon 3 factorial plus 11 factorial upon 4 factorial plus and so on. Anybody? 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 There is an observation involved, a very smart observation. This is 8 factorial. This is 9 into 8 factorial upon 2 factorial. This is 10 into 9 into 8 factorial upon 3 factorial. 11 into 10 into 9 into 8 factorial whole upon 4 factorial plus and so on. Is this much understood? We saw the least factorial, which is 8 factorial in the numerator, and we saw that 8 factorial is actually sitting commonly in each of the terms. Yes, so I can take out 8 factorial common. I'll be left with 1 plus 9 by 2 plus 10 into 9 by 6 plus 11 into 10 into 9 by 24 plus and so on. What do you think I should do now? Huh? What do you think I should do now? This much you've understood? But what do you think I should do now? What is the advantage of reaching this step? Any clue? Can you foresee? Can you see what should be the next step? Very quickly, guys. Very quickly tell me. Anybody, any clue, any idea? Huh? Very smart question. I'm telling you 99.5 at least. Not just 99, it's a 99.5 percentile question. I'm raising the bar. 8 factorial. If you write 8 factorial as 8 into 7 factorial, that gives you the liberty to go and multiply 8 in every term. And what is the profit of doing that? You have 7 factorial outside. Here you have 8 plus 9 into 8 upon 2 plus 10 into 9 into 8 upon 6 plus 11 into 10 into 9 into 8 upon 24 plus and so on. What is this? Haha, very true. But what is this? Tell me. What is this? Can this be written as 8C1? Is this 8C1? Yes. Is this 9C2? Huh? Is this 9C2? Yes or no? Huh? Is this 10C3? Is this 11C4? Come on, tell me. Amazing, isn't it? Could you have imagined we started with solving a series? We thought it's a question of sequence and series. And huh? Yes? You've got this? I want the sum up to 20 terms. What will be the 20th term? Who will tell me? What will be the 20th term? Anytime binomial is coming into picture, anytime sequence series is coming into picture. This is the switch which keeps happening in mathematics, and that is why you must practice hard and you must focus hard on these sessions. 8C1, 9C2, 10C3, 11C4, what will be the 20th term? What will be the 20th term, everybody? You have 8, 9, 10 and so on. This is your AP. What is the 20th term? A plus n minus 1 times d. This gives you 27. 27, Kirtika, 27. So your 20th term will be 27C what? 8 minus 1, 7. 9 minus 2, 7. 10 minus 3, 7. 11 minus 4, 7. Here you will get 20. So the 27 minus 20 is 7. The difference between upper and lower is 7. That is how I got 27C20. Anybody, any confusion? Quickly tell me. Yes, 27. Very good, Parag. So 8, 9, 10, 11 and so on was AP, right? That is how I got the 20th term upper index as 27. And then I saw that upper minus lower, upper minus lower, upper minus lower is always 7. So I wrote 20 over here as the lower index. This is my 20th term. I want this complete sum. How do you think I can calculate this sum? How do you think I can calculate this sum? It's a very intelligent question, bound to get in the paper. Even partially, an intermediate part of this question can pop up in your paper. That's how important this is. Which formula, Sai? Somehow you are right, but which formula? Tell me. Huh? NCR plus, remember, NCR minus 1 is N plus 1 CR. Yes or no? Yes or no? Very, very good. We need to add and subtract 8C0. Perfect job done, yaar. Perfect job done. So 8C0 is added. What do you have as the rest of the terms? 8C1 plus 9C2 plus 10C3 plus 11C4 plus and so on. And this is 26C19 and then 27C20. And you also have to subtract 8C0. Is this making sense? Why did you do that, ma'am? Because NCR plus NCR minus 1 is N plus 1 CR. When you add both of them, what do you end up getting? 9C1. When you add 9C1 and 9C2, what do you end up getting? 10C2. When you add 10C2 and 10C3, what do you end up getting? 11C3. Again, 11C3 and 11C4, what do you end up getting? 12C4 and so on. Eventually, what will you get? What will you get? Tell me. You will get 26C18. So 26C18 and 26C19 will give you what? 27C19, and 27C19 plus 27C20 will give you 28C20. 28C20. So eventually you will get 28C20 minus 8C0, which is 1. Very, very good. And there is obviously a 7 factorial outside. Is this clear? Is this clear? C is the right answer, everyone. Please tell me if this question is absolutely clear. It's very, very, very important. Did you understand how have I added consecutive binomial coefficients? Yes or no? Did you understand? Did you understand this, or you want me to explain again? Is this clear? Chandra, Shri, Kirtika, everybody, hashtag HDCC. Keep on adding the pairs. Keep on adding the pairs. 8C0 plus 8C1 gave you 9C1. 9C1 plus 9C2 gave you 10C2. 10C2 plus 10C3 gave you 11C3. And so on. In the end, you get 27C19 plus 27C20, which gives you 28C20, and you have a -1 here. So 28C20 -1 is the final answer along with a 7 factorial. Is that making sense, everyone? Parag, is this clear? There should be no confusion because this question is a fantastic question involving both concepts of sequence series and binomial theorem. If there is even one step where you have a doubt, please ask me right now. Yes, Hanif? Hashtag HDCC, absolutely clear. Appreciated. Remember the drill. Whenever you get series involving factorial, approach should be the on-point approach. You understood what we did here? We took out 8 factorial common. Then we wrote 8 factorial as 8 into 7 factorial. We multiplied the 8 inside and converted into binomial coefficients. And then it was the magic of results. This result. Which result? This result. Cool? Shall I move ahead? Next question on your screen, guys. Please brace yourself. Pull up your socks. This is going to be a wonderful roller coaster journey which will give you tons of learning and will level up your preparation for sure. Let's go to the next question, which is this. Coming from the land of PNC, number of words which can be formed using the letters of the word cauliflowers in which vowels are always in alphabetical order is M, and the words in which no two vowels are together is N. So there are two conditions, there are two things about which the question is talking about. One is M and one is N. One is M and one is N. Tell me, how do you plan to solve this question? How do you plan to solve this question? 1 second. Yeah. Two things the question is talking about. One, it says M is the number of words which can be formed using letters of the word cauliflowers in which vowels are always arranged in alphabetical order. And next, N is what? Words in which no two vowels are ever together. What is the concept being captured here? Tell me. See, each question which I'm sharing with you is not a low level or a low quality question. Every question is going to be rich, multi-conceptual. Every question will help you revise exactly those concepts and ideas on which there is a big spotlight of NTA right now. Okay? Wow, Kirtika is giving me a suggestion. So I have CAULIFLOWERS. How many letters? 12 letters. Okay, all right. Let's first compute M, okay? M is number of words which can be formed using these 12 letters. Vowels are always in alphabetical order. How many vowels? A is a vowel, I is a vowel, U is a vowel, O is a vowel, E is a vowel. So all A, E, I, O, U, 5 vowels are present in this entire word cauliflowers. Exactly once. There is one A, one E, one I, one O, one U. 5 vowels. I want to arrange them in alphabetical order. So out of these 12 letters, I choose these 5. Is that okay? First, okay, wait a second. Chandra has given a suggestion. First, separate vowels and arrange them in alphabetical order, then keep it constant and play with the other letters and find the number of words. Wow. So actually, I will not be selecting the vowels. I want to make 12 letter words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What I will be doing is, out of these 12 blank places, I will be selecting 5 places. I will be selecting 5 places. Out of these 12 places, I will be selecting 5 places to arrange my 5 vowels. But let's say the 5 places that I choose are this place, this place, this place, this place, and this place. Suppose these 5 places I have chosen. Obviously, it's a linear fashion. It's a linear arrangement. It's not a circle, no? It's a line. So obviously, this is the first position, this is second position, this is third position, fourth position, fifth position. Yes, I can assign numbers to the position, na? Right? Suppose randomly I am saying these 5 places have been chosen. Now I want to arrange vowels in alphabetical order. So obviously, A has no choice but to be kept here. E has no choice but to be kept here. I has no choice but to be kept here. O has no choice but to be kept here. U has no choice but to be kept here. So whatever 5 places you choose in 12C5 number of ways, you can always assign them position as the first, second, third, fourth and fifth place. And A, E, I, O, you have no other choice but to sit at those places in the alphabetical order, which is only one way. So you can select 5 places and arrange these vowels in the 5 places in only one way. One way is the alphabetical order way. Yes, after you have arranged the vowels, then you are left with the 7 consonants. So 7 consonants can be arranged in the remaining 7 places in how many ever ways? 7 consonants are what? C, L, F, L, W, R, S. 7 factorial upon 2 factorial. C, L, F, L, W, R, S. L is repeating twice. 7 factorial by 2 factorial. This is M. Any confusion, guys? Any confusion? Is this clear? Is this clear? Yes, ma'am. No, ma'am. This one way is the alphabetical order way. Yes? Is this cool? Is this cool? Arrange the vowels in alphabetical order randomly. Randomly? No, Hanif. Alphabetical order is not randomly. Alphabetical order is a fixed order. There is only one way in which you can arrange 5 vowels in alphabetical order. So not random, it's a fixed way. That's why I've written into 1. Okay, and the rest in 5040 ways, which is 7 factorial. Not 7 factorial, 7 factorial upon 2 factorial. This is the arrangement of consonants, and consonants are what? You have C, L, F, L, W, R, S. C, L, F, L, W, R, S. L is repeating twice. That is why divided by 2 factorial. This is the arrangement of consonants. This is the arrangement of consonants. What about N? N is the number of words in which no 2 vowels are together. Whenever you want no 2 girls to sit together, no 2 boys should sit together, no 2 vowels should appear together, what is the concept which gets active here? What is the concept? The line itself, the phrase itself is giving you a hint of the concept, the idea which will be applied now. Tell me. Very quickly tell me. No 2 vowels can sit together. No 2 girls can sit together. No 2 boys can sit together. What is the concept which gets applicable here? What is the concept which immediately comes into action in such a situation? Huh? It is none other than the gap method, everybody. The gap method. Gap method, Hanif. It's the gap method. What do? If you don't want any 2 vowels to sit together, you will first write down all the consonants. You have C, L, F, L, W, R, S. When you arrange the consonants, you are left with how many places? 1, 2, 3, 4, 5, 6, 7, 8. These are your 8 gaps. In between the consonants and by the end of the consonants, everything included gives you 8 gaps. In these 8 gaps, you will arrange the vowels. When in these 8 gaps you arrange the vowels, it will be ensured that no 2 vowels are appearing together. So out of these 8 places, you select any 5 places because you have 5 vowels. Out of these 8 gaps, you select any 5 gaps, and in these 5 gaps, you arrange the 5 vowels in 5 factorial ways. When these vowels will be arranged in these gaps, orange gaps, no 2 vowels will appear together. That is for sure. Once you have made sure of this, now you know that these consonants which are sitting here are not bound to sit here. They can also change places among themselves. So these are 7 consonants which can change places among themselves in 7 factorial upon 2 factorial ways because L is repeating twice. This is your N. That's it. That's it. You are done. Can you imagine such a non-lengthy question but such a common sense, practical, rational question? If you can imagine the situation, it's very simple for you to decode the answer. Is this clear? Is this absolutely clear, people? Please tell me very, very carefully. You have to understand what did the language of the question say and how have we understood the language and then solved the question. Is this hashtag HDCC completely clear? Is this clear? M is clear, N is clear. Can you compute 14M by N? It's very simple. Can you compute 14M by N? This will come out to be 1.65. You can calculate 14M by N. Is this clear? In PNC, the gap method, the string method, what is the string method? Where you say that these two girls should always sit together. Okay, gap method comes when you say the two girls can never sit together. In that case, you compute the gaps and in those gaps, you make these girls sit so that they are never together. But there is another contrary situation where you say these two girls should always be together. In that case, you consider them like tying with a string. You are taking both the girls and tying them with a string, treating them as one single unit. Wherever they'll go together. So you treat them as one single entity. Okay, that is a string method. String method and gap method both are extremely important and high weightage from PNC and very easy to master as well. Chandra, you must know if you have, let's say, A, B, 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 C, D, D, E, F. All these letters you want to arrange. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. If there were 9 distinct letters to be arranged in 9 places, that could have been done in 9 factorial ways. But right now you have 3 B's, so you divide by 3 factorial, 2 D's, you divide by 2 factorial to avoid repetition. So we had 7 consonants, but L was repeating twice, so 7 factorial upon 2 factorial. That's permutation when you have repeated objects. Permutation when you have repeated objects. Some objects are repeating, that's what you do. Okay? Alrighty, moving on to the next question, everybody, comes this one. Fantastic again. Fantastic. Let's see. Let's see how many of you all are able to crack this. Let's see how many of you all are able to crack this. Wonderful. It says 3, 4, X, 5, Y. This is a 5-digit number. X and Y are digits. X and Y are digits. So X and Y are actually coming from the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Divisible by 36. Anybody? This number I want divisible by 36. Now when you say 36, 36 is a composite number. It's not a prime number. So I need to do its prime factorization. This is 9 into 4. Stop here. Don't do further prime factorization like 3 into 3 into 2 into 2. No. Because I have a direct divisibility test for 9. I have a direct divisibility test for 4. So if this number satisfies the divisibility test of 4 and of 9, we will say it is divisible by 36. Why should be even, ma'am? This is the catch, Hanif. This is the catch. This is the catch. A number is divisible by 4 when? Who knows the divisibility test of 4? Everyone tell me. Who knows the divisibility test of 4? Who knows the divisibility test of 4? Anybody who knows the divisibility test of 4? Anybody who knows the divisibility test of 4? Yes, ma'am. No, ma'am. What is the scene? Anybody who knows the divisibility test of 4? Yes. Absolutely correct. Last 2 digits combined should be divisible by 4. Last 2 digits, that means 5y. This has to be divisible by 4. This has to be divisible by 4. So what all values can y take? 52, is it divisible by 4? Yes. 56, is it divisible by 4? Yes. 50, no. 51, no. 52, Yes. 53, no. 54, no. 55, no. 56, yes. 57, no. 58, no. 59, no. That's it. The last two digits can be 52 or 56. The last two digits can be either 52 or 56. So I have only two options. My number can look like 34x52 or it can look like 34x56. It can either look like 34x52 or it can look like 34x56. What about x now? Now both these type of numbers are 100% divisible by 4. I also want the numbers to be divisible by 9. Divisible by 9, what is the test? Divisible by 9, what is the test? A number is divisible by 9 when the sum of all digits is divisible by 9. When sum of all digits is divisible by 9. So I want 3 plus 4 plus x plus 5 plus 2 to be divisible by 9. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 plus x is the sum right now. And here what is the sum? Tell me. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18. 18 plus x is the sum. Very good. What all can x take? What all values can x take? So that 14 plus x is divisible by 9. 14 plus 0, no. Plus 1, no. 2, no. 3, no. 4, yes. X can be 4 because 14 plus 4 will give you 18, which is perfectly divisible by 9. 14 plus 5, no. 6, no. 7, no. 8, no. 9, no. That's it. X can only take 4 in the first case. What about this? X can be 0. Yes, in that case 18 will be divisible by 9. Or x can be 9. 27. Here also it's true. 0 or 9. 27 is divisible by 9. So this means my possible numbers can be 3, 4, 4, 5, 2. This can be 4, 3, 4, 4, 5, 2. Then you have 3, 4, 0, 5, 6 and 3, 4, 9, 5, 6. That's it. Hi Aryan, good evening. Do you understand? Not a very smooth sailing question, but not a very difficult question as well. You can slip in this question if your concepts are not clear about divisibility. And divisibility is a hot shot topic, guys, to occur in your paper from PNC. Hot shot. Very important, very relevant, highly probable to be asked in your paper. Loved by NTA throughout. Loved by NTA. Is this cool? This is a very different type of a question where directly the divisibility test or divisibility format is not being applied. It's a different type of question where the divisibility concept is being applied. Is this question clear? Is this question clear? Yes? Awesome. Then we have how many number of 5-digit numbers which are of this form divisible by 36? We have only 3 numbers. We have only 3 numbers. Yes, only 3 numbers. Is it cool? Is this absolutely clear? Now it's time for the next question, people. Come on. Come on, come on, come on. Today, no mercy. No mercy whatsoever. It's algebra, everybody. Algebra questions have one problem. Sometimes they are very easy, very simple, but the language is way too much. Like in the previous question also, the language might seem confusing, but the question was pretty straightforward if you know the divisibility test. Question before that also, pretty good, but seeming confusing. When you look at it, when you read it, it seems heavy or confusing, but when you start solving, if your concepts are clear, it's a smooth sail. It's a pretty smooth sail. Come on, guys, read this question. Very important. Very, very important. Tell me. Quick. Tell me. All the face cards from a pack of 52 playing cards are removed. All the face cards from the remaining pack. So 52 minus 12. Face cards are 12. 52 minus 12 gives you 40. 40 cards are remaining. From the remaining pack of 40 cards, half of the cards are randomly removed without looking at them and randomly drawn 2 cards from the remaining half. If the probability that 2 cards drawn are both aces, then the value of P is what? Do you understand? 52 is the total number of cards. From there, you've removed 12 face cards. Okay, fine. You're left with 40 cards. Okay, now 40 cards you are dividing into 2 sections, 20 and then 20. These 20 cards are randomly removed and these 20 cards are remaining. Question says from the remaining 20 cards, 2 aces are drawn. Question says from the remaining 20 cards, 2 aces are drawn. What is the probability of drawing 2 aces? Now see, in total you have 4 aces. In total you have 4 aces. Depending upon how many aces are removed in these 20 cards, I will be drawing aces from the remaining 20 cards. Are Baba, the 20 removed cards are randomly removed, na? The cards which are removed are randomly removed. It might happen that 1, 2, 3 or all the 4 aces have also been removed with the 20 cards. Right? So depending upon how many aces have been removed from the 20 cards along with 20 cards, that will imply how much is the probability of getting ace cards from the remaining 20 cards. Is this making sense? I'll repeat again. These 20 cards that you are removing, bache, you are removing randomly. You are removing randomly. So it might happen that when you remove the 20 cards, no ace cards are there in the removed 20 cards, or it can happen 1 ace card is removed along with this bunch of 20 cards, or 2 ace cards are gone, or 3 ace cards are gone, or all 4 ace cards are gone. So depending upon how many ace cards are there which are removed in my 20 cards that are removed, will I be able to compute the probability of getting ace cards from the remaining 20 cards. Okay? Is that clear? And that is why the probability of getting a ace card, or rather 2 ace cards, probability of getting 2 ace cards is going to be determined using the total probability theorem. Now, Bayes' theorem, if you remember the formula for Bayes' theorem is one of the highest weightage topics in probability, but the denominator of Bayes' theorem is a result of the total probability theorem only. So here I am applying total probability theorem. Now don't say, ma'am, Bayes' theorem is important, total probability is not important, because in the denominator of the Bayes' theorem formula is nothing but the total probability concept only. Okay, how will you calculate? What are the different events under which the probability of 2 ace cards withdrawn will be impacted? Tell me. Probability of getting 2 ace cards. Hi Ganesh. Probability of getting 2 ace cards. Come on, tell me. 0 ace cards removed. 0 ace cards removed in the bunch of 20 removed cards. Let's say this is your event A. Multiplied with probability of getting 2 ace cards when event A has occurred. Probability of the event multiplied with probability of what you want when the event has happened. This is one part plus another part. Come on, tell me probability that 1 ace card is removed. 1 ace card is removed. This is your event B. 1 ace card is removed. This is your event B. So in the lot of 20 cards which are removed, 1 ace card is removed. Then multiplied with probability of getting 2 ace cards given event B has occurred. Given that event B has occurred. Or it can happen, what? Probability that 2 ace cards are removed. 2 ace cards are removed. Are you understanding the logic? 2 ace, a beautiful question. 2 ace cards are removed. Let's say this is event C multiplied with probability of getting my desired outcome, which is 2 ace cards, given that C event has already occurred. Given that event C has already occurred. Is this making sense? Now you might say, ma'am, 3 ace cards can also be removed. If 3 ace cards will be removed, I will be left with only 1 ace card in the lot. And then the probability of drawing 2 ace cards will be 0. So I will not write that now, because it will be plus 0. Similarly, if all 4 ace cards are removed in the lot, then I am left with 0 ace cards. So probability of drawing 2 ace cards again 0. So plus 0. Why do I have to write both those cases? No, I don't have to write both those cases. I will just write till here. What is the probability that 0 ace cards are removed? So from the lot of 40 cards, you are removing 20 cards. From the lot of 40 cards, you are removing 20 random cards. And that can be done in 40C 20 ways. There is no condition. This is your total number of outcomes. What is the favorable? That 0 ace cards are removed. So out of 4 ace cards, 0 are removed. Out of the remaining 36, 4 are removed. Not 4, 20. Out of the 4 ace cards, none are removed. Okay? And out of the 36 remaining, all 20 are removed. Multiplied with, if event A has occurred, what is the probability of getting 2 ace cards? Tell me. You want 2 ace cards in the remaining 20 cards. So from the remaining 20 cards, you can get 2 cards in 20 C2 ways. But you want both of them to be aces. Now this event has occurred where 0 ace cards are removed. So all 4 ace cards are there left behind. From those 4 ace cards, I want 2 ace cards, so 4C2. Are you understanding? So the first bracket is for the 20 removed cards, out of which none of the aces are removed. And once that event has occurred, then the next expression is what? From the remaining 20, you are selecting 2 cards. And because all 4 ace cards are intact, that is why 4C2 is the ways in which you can get 2 ace cards. This is your first expression. What is the second expression? Again, 20 cards can be removed in 40C 20 ways. But now 1 ace card is removed. So from the 4 ace card, 1 ace card is removed. And from the remaining 36 cards, the 19 leftover cards are removed. 19 plus 1 is 20. So this is the fashion in which the cards are removed. Okay? Okay, multiplied with 20C2 is the total. And you want 2 ace cards, you want to select 2 ace cards given that 1 ace card has gone. If 1 ace card has gone, you are left with 3 ace cards. From the 3 ace cards, you can select 2 ace cards in 3C2 number of ways. Is this cool? This is your second expression. This is your second expression. What about the third expression? Again, from 40 cards, you are removing 20 cards. And this time, 2 ace cards are removed. So out of the 4 ace cards, 2 are removed. You are left with 18 removed cards. So from the 36, these 18 are being removed. 2 ace cards, 18 non-ace cards. Multiplied with, now you want to select 2 cards, but 2 aces have been removed. You are left with only 2 aces in the lot. So out of the 2 aces, you can select both the aces in 2C2 number of ways. This is your third part of the answer. Are you getting my point? First part, second part, third part. Beautiful, beautiful question. Beautiful, beautiful question, people. Did you understand the logic, the flow, the reasoning behind this? We are applying the total probability theorem. Depending upon how many aces are removed along with 20 cards, that will determine that from the remaining 20 cards, 2 aces that I'm withdrawing, what is the probability of it? Is this clear? Guys, is this absolutely, absolutely clear? Please tell me right now. Stop me right now if there is any doubt. You don't need to do anything. Just calculate. Very, very, very beautiful calculation. Easy calculation. What will you get? Your probability is already given to you. P times 38C20. P times 38C20 upon 40C20 into 20C2. You can see For yourself, 40C20 into 20C2 is occurring in every expression. 40C20 into 20C2, 40C20 into 20C2. So this is your denominator. When you solve the numerator, what do you get? When you solve the numerator, what do you get? Can you tell me? Huh? You know what will you get? 36C20 plus 36C19 plus 36C19 plus 36C18. This is what you will get as the numerator, and denominator will be the same, 40C20 into 20C2. You know, as a matter of fact, 36C19 plus 36C20 is nothing but 37C20. And what is this? This is 37C19. But 37C19 plus 37C20 gives you 38C20. So eventually your right hand side becomes P times 38C20. This P is nothing but 6. When you will solve, you will realize this P is nothing but 6 upon 40C20 into 20C2. Compare it with what is given in the question, 38C20, and here you have 40C20 into 20C2. This gets cancelled out. P is straight away equal to 6. P is straight away equal to 6. Wonderful, wonderful question. Questions like this, you are bound to get in probability, everybody. You are bound to get questions like these in probability. And you must know how to crack them. Because it's not something which is very challenging. It's just going to require a lot of focus from your side to understand that the question is based upon the total probability concept. What are the different events under which my probability will be hampered or affected? Accordingly, apply the total probability theorem, calculate and get the answer. Is this question clear, guys? Is this question hashtag HDCC? Because I am going to move ahead now and talk about the further questions. Is this question completely clear? Is this question completely clear? Huh? Is this question completely clear? Any doubt? Anyone stop me right now? Is this absolutely clear? You are not allowed to go with any iota of doubt as well in your head. Okay? Moving ahead, your answer to this question is 6. Let's jump on to the next question. Tell me, if x and y are positive real numbers such that x inverse plus y inverse is 1, what is the minimum value of 31 to the power x upon x plus 65 to the power y upon y? Think. Think. Think, think, think. See, even if some of the chapters are there which you have not studied in algebra, you can try to understand the most important concepts from those chapters through this session. The questions that we will solve are completely based upon only and only the high weightage concepts and ideas. So when you solve the question, along the way also you get to revise a lot of concepts which are important from JEE Main point of view. Is that clear? So don't take these questions lightly. Don't take these questions lightly, because even if any one chapter is completely left by you, you can at least prepare its important subtopics by solving these questions which are coming along the way from that chapter. Okay? Alright. Tell me, what will you do in this question? You want minimum value of this expression. Minimum value of this expression. X and y are positive real numbers such that x to the power minus 1 plus y to the power minus 1 equals 1. Oh, that means 1 upon x plus 1 upon y equal to 1. X plus y is equal to xy. This is a fact or a given piece of information which we have to use. This is given to us indirectly, but this is given to us. What is the minimum value of 31 to the power x upon x plus 65 to the power y upon y? What do you think is the hack to crack this question? You know what is the hack? You have 31 to the power x upon x, 65 to the power y upon y. You know what is the hack? It's a very, very famous, very commonly occurring type of a question with respect to your JEE Main perspective. Very common. You split it. You break it into equal parts. You have 31 to the power x and 65 to the power y as two quantities which are positive 100%. But you will be using the AMGM inequality not directly on these quantities, rather you will split them into equal parts. But how many equal parts? You will split them into equal parts, but how many equal parts? Huh? How many equal parts? Of course, it's very obvious for you to say, ma'am, the question is asking minimum value, so AMGM inequality will come into action. And I know your AMGM inequality is only valid for non-negative quantities. It's only valid for non-negative quantities. And here I don't have non-negative, in fact, I have positive quantities. So I can apply my AMGM, but not on 31 to the power x and 65 to the power y. Rather, I will split the quantities. How? How will I split them into equal parts, and in how many parts will I split them? I will split 31 to the power x into y equal parts. How? 31 to the power x plus 31 to the power x plus 31 to the power x y times plus 65 to the power y, 65 to the power y, 65 to the power y, x times. Can you see this? Can you see this? Huh? Can you see this? How many quantities I have? X plus y number of positive terms. I have x plus y number of positive terms. Their arithmetic mean is greater than or equal to their geometric mean. So, I have taken all these quantities and I have taken all these quantities. So, I have x plus y number of terms. X plus y is the total number of terms. X plus y is the total number of terms. Now, their arithmetic mean will be 31 to the power x plus 31 to the power x y times plus 65 to the power y plus 65 to the power y x times. So, upon x plus y. Remember, sum of terms upon total number of terms is greater than or equal to the what? 1 upon x plus y, because this is the total number of terms, product 31 to the power x into 31 to the power x y times 31 to the power x whole to the power y. So, 31 to the power xy. Similarly, 65 also to the power xy. So, what do you get? Right hand side becomes what? 31 into 65 to the power xy upon x plus y. xy upon x plus y. Huh? Yes or no? Yes or no? Yes or no? But x plus y is same as xy. Question had said x plus y is same as xy. X plus y is same as xy. So, this is cancelled out. You are left with 31 into 65. What about your left hand side? Baba, x plus y is same as xy, no. So, 31 to the power x y times 31 to the power x y times plus 65 to the power y x times upon xy upon xy. This gives you 31 to the power x upon x plus 65 to the power y upon y. This is your left hand side, which is greater than or equal to 31 into 65. This is exactly what you wanted, 2015. Yes or no? This is exactly what you wanted. Yes, ma'am. No, ma'am. Very quickly, guys. Come on, tell me. This is exactly what you wanted. This is your expression. And its minimum value is coming out to be alpha. This is actually alpha. Brilliant question again. Very simple AMGM inequality, which has been used in a very powerful sense in this question, because not just AMGM directly we have used a hack, and the hack is to split the number into multiple equal parts. Why do you always split in equal parts? Because you know that AM is equal to GM if and only if all the quantities are equal. To ensure that to hold true, we always split it into equal parts. So, y equal parts, x equal parts. All quantities x quantities are equal, y quantities are equal. In total, there are x plus y number of quantities whose AM is greater than or equal to GM. Is this clear? Any doubt, any confusion? Stop me right now. Very, very famous concept, AM, GM. That too being applied in a very famous setup, which is splitting the number. You break it up into multiple equal parts or split it into multiple equal parts depending upon the need of the situation. Okay? Is it cool? Anybody, any confusion? Tell me, is it cool? Yes? Perfecto then. Hashtag HDCC. I hope for everybody. Come to this question now. Wonderful again. Wonderful. Let Sn, where n belongs to set of naturals, be the sum of an infinite geometric series whose first term is n and common ratio is 1 upon n plus 1. Whose first term is n and common ratio is 1 upon n plus 1. Okay? Sn is the sum of infinite geometric series whose first term is n and common ratio is 1 upon n plus 1. Okay, so what is Sn equal to? A upon 1 minus r. What does this give you? N upon n plus 1 minus 1, and this is n plus 1. So you get n plus 1 upon n, which simply gives you n plus 1. Very simple calculation, but I think this is something which you must calculate right in the beginning and keep with yourself, that Sn is n plus 1. Now you want to calculate limit of this expression, which doesn't look very beautiful, but trust me, it's not very challenging as well. It's very, very, very important. Question is from sequence and series, but immediately limit has come into action. That to infinite limit because it's an infinite series. How do you plan to calculate? Now here there is an idea being used. There is an idea which is being used here. What is the idea? This idea is very important. I'll quickly share with you. Suppose you have limit n tends to infinity of an cube plus bn square plus cn plus d upon say pn cube plus dn square q rn plus s. Okay, numerator and denominator have the same degree. In that case, what is the limit? The limit always comes out to be a by p, which is the ratio of the leading coefficients, ratio of the highest degree variable, ratio of the coefficient of the highest degree term, ratio of the coefficients of the highest degree term. So coefficient of highest degree term in the numerator, coefficient of highest degree term in the denominator, take the ratio, that's the answer. How do you get this? Because you take out n cube common, you're left with a plus b by n plus c by n square plus d by n cube. Again, take out n cube common. Again, p plus q by n square, q by n plus r by n square plus s by n cube. Is this clear? Is this clear? N tends to infinity, this tends to 0, 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 this gets cancelled, you are left with a upon p. This idea is what gets applied here. You don't need to do this all the time. Just remember, when you have numerator polynomial upon denominator polynomial, both of the same degree, then just catch hold of their leading coefficients. Their ratio is the answer. Very, very important idea, guys. The moment you reach this stage, don't calculate any further. Ignore everything. Catch hold of the leading coefficient from top and from bottom. Ratio is the answer. Report it as the answer. Report it straight away as the answer. Is this clear? Now let's start. S1 into Sn, what will you do? S1 into Sn, see, I'll write S1 into Sn plus S2 into Sn minus 1 plus S3 into Sn minus 2 plus and so on Sn into S1. Whole upon S1 square plus S2 square plus S3 square plus and so on Sn square. Let's calculate the limit afterwards. First, let's resolve this expression. S1 into Sn, S2 into Sn minus 1, S3 into Sn minus 2. How do you compress it? This is summation SR into S what? n minus 1 plus 2 is n plus 1. 3 plus n minus 2 is again n plus 1. The difference, can you see this? The sum, not the difference, the sum is always n plus 1. Yes or no? So I will write Sn plus 1 minus r. Please check. If r is 1, you get n plus 1 minus 1 gives you Sn. If r is 2, you get S2 into Sn plus 1 minus 2, so Sn minus 1. If r is 3, you get S3 into Sn plus 1 minus 3, so Sn minus 2, and so on. And so on upon summation Sr square. Yes or no? Yes or no? R going from 1 to n, R going from 1 to n. Now what is the solution? If Sn is n plus 1, I calculated, right? Sn is nothing but n plus 1. So Sr is what? Summation Sr into Sn plus 1 minus r. What is Sr? R plus 1. What is n plus 1 minus r? N plus 1 minus r. So n plus 1 minus r plus 1. So n minus r plus 2. SR you calculated, no? Sn you know. Sn you know is n plus 1. So you can write S with whatever lower index. Whatever lower index, I don't care. And summation SR square means r plus 1 whole square. What will you do next? Tell me, what will you do next? Tell me, what will you do next? This bracket can be manipulated. How? 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 N plus 3 minus r plus 1. Please check. N plus 3 minus r minus 1. So n minus r plus 2, you are getting your bracket back. You can rewrite this as n plus 3 minus r plus 1. What will happen then? R plus 1 gets multiplied with this, r plus 1 gets multiplied with this. So your numerator becomes what? Your numerator becomes what? You have r plus 1 multiplied with n plus 3 minus r plus 1. Oh, and whole upon summation r plus 1 whole square. What does this give you? Summation r plus 1 into n plus 3 minus summation r plus 1 whole square, whole upon summation r plus 1 whole square, whole upon summation r plus 1 whole square. Please check this. Tell me, you're getting this right? So eventually I can say numerator is minus of summation r plus 1 whole square, minus of summation, minus, let me take it outside, r plus 1 whole square plus summation, you have what? R plus 1 into n plus 3. N plus 3 simply comes outside and you have summation r plus 1 whole upon summation r plus 1 whole square. Can you open this up now? Come on guys. Active, active, be active. When you open this up, r is going from 1 to n. So you have 2 square plus 3 square plus 4 square plus n plus 1 square, but there is a minus sign ahead. Plus n plus 3 as it is. Here what do you have? Summation r plus 1, r going from 1 to n. 2 plus 3 plus 4 and so on till n plus 1. Alright. Whole upon summation r plus 1 whole square. So 2 square plus 3 square plus and so on plus n square. What is the way forward? Yeah, but what is the way forward? Carefully observe. You don't have sum of squares of first n plus 1 natural numbers. One square is missing. One square is still missing. So what you do is you add a 1 square and you subtract a 1 square. And there is a minus sign outside. You add a 1 square, you subtract a 1 square. There was already a minus sign outside. Similar problem is sitting in this bracket also. This is not sum of first n plus 1 natural numbers. The plus 1 is missing. So what you do is, you add a 1 and you subtract a 1. You add a 1 and you subtract a 1. Similarly, in the denominator, you add a 1 square, you subtract a 1 square. Now what you have is something which is a pretty comfortable situation for you, because this much part is what? Sum of squares of first n plus 1 natural numbers, which is n plus 1, 2n plus 1. That means 2n plus 3 upon 6 with a minus sign. N plus 1, 2n plus 1 by 6, n is nothing but n plus 1 minus 1. Are you understanding my point? Plus n plus 3 as it is. Inside what you have? Sum of first n natural numbers, which is n, and sum of first n plus 1 natural numbers. N plus 1 by 2. So this by 2 minus 1. Wow. Wow. Upon, again, sum of squares of first n natural numbers. N plus 1. This is n plus 1. Sum of squares of first n plus 1 natural numbers. Again, what? What? N plus 1, 2n plus 1, which is this by 6, and minus 1. Don't forget the minus 1. Don't forget the minus 1. Now tell me, what is the limit of this expression as n tends to infinity? You don't have to calculate this or simplify this expression any further. No, you don't have to. You don't have to, because you know the drill. You know the drill. If numerator and denominator of the same degree, just catch hold of the leading coefficient and compute the ratio. What is the degree of the numerator? 3, n cube. The polynomial here will be cubic polynomial. What is the leading coefficient? N into 2n. So 2n cube by 6 minus 2 by 6. This is the leading coefficient from the first bracket. What about the next one? N plus 1 into n plus 2 gives you n square by 2. So into n plus 3. So n cube by 2. So 1 by 2. 1 by 2. What about, this is the leading coefficient from the second bracket. What about the denominator? N into 2n. So 2n cube by 6. 2n cube by 6. That means 2 by 6. That's it. What is your answer? 1 by 2. This is how you apply your mental math. A quick math. But this can only be applied when you know the idea. What is the idea of infinite limit with polynomial upon polynomial? The idea says when you have the same degree of polynomial in the numerator and denominator and your limit is tending to infinity, just catch hold of the leading coefficients and take their ratio. Here also in the end, there was no need to simplify this expression any further. The moment you reach here, you had to realize that each of these expressions are representing my cubic polynomials in n. I just need the coefficient of n cube. From here, coefficient of n cube was minus 2 by 6. From here, it was 1 by 2. So, added the leading coefficients, and here, the coefficient was 2 by 6. Yes, Hanif, Kirtika, Ganesh, Sai, Aryan, Chandra, everybody tell me, is this cool? Is this question understood? This was looking like a typical difficult question because of this giant expression. But actually, when you converted it into the summation format, it kind of started looking pretty easy, pretty simple and manageable. All it involved was this manipulation. This is a star step. And this is not a compulsion. If you would have wanted, you would have just done r into n, r into r, r into 2 and so on. Even that would have given you the right answer. This is just an additional time-saving hack which I'm telling you. This manipulation. Okay, this rewriting of n minus r plus 2 as n plus 3 minus r plus 1. This step is manipulation, which is a added advantage if you wish to know. Otherwise, if you in a plain manner, you multiply both these brackets and distribute the summation, even that will give you your answer. Not a problem at all. Okay, is this question hashtag HDCC, guys? Do not forget summation r square, summation r cube. Formally, they are deleted from the syllabus, but actually they are not deleted from the syllabus. It's very much in the syllabus. So you must realize that here I have just used sum of first n natural numbers. First n plus 1 natural numbers, sum of squares of first n plus 1 natural numbers, again sum of squares of first n plus 1 natural numbers. Very, very important. And this idea is the catch of this question. This is a superstar. It's a rock star. Limit n tends to infinity. How do you calculate the limit? Is it okay? Hashtag HDCC everyone. I am moving ahead to the next question. Tell me. Again, something which will blow your mind. Tell me. What do you think is the idea involved to crack this question? Tell me. Quick. Summation TR is given to you, R going from 1 to n, as an expression involving n. What is this? Oh. Tell me. You want 1 upon R under root TR. What is this, Baba? 1 upon R under root TR. Do you have the general term? You have Sn with you. Do you have Tn with you? No. The concept of this question is, how do you get Tn from Sn? Sn is with you, I agree. The entire expression for Sn is perfectly with you. What about Tn? Sum of first n terms is with you. Do you have the general term with you? No. How will you get it? How will you get Tn from Sn? How will you get Tn from Sn? How will you get Tn from Sn? Anybody? Come on people, this much you should know. Very important. If you have Sn with you, you want Tn. How do you get Tn from Sn? How do you get Tn from Sn? Very common sense oriented question. Heavy common sense required. What is Sn? Sum of first n terms. What is Sn minus 1? Sum of first n minus 1 terms. So when you subtract Sn minus 1 from Sn, all you are left with, bache, is Tn, because all other terms get cancelled. Very good, Sarah. Very, very good. Tn is nothing but Sn minus 1. Yes or no? That's it. This is the only catch of this question. Guys, if you don't know this, you are way behind in sequence and series, let me tell you. Don't just talk about AP, GP, AGP, telescopic series, etc., etc. This is a basic, fundamental, and devil lies in the details, I always tell you. If you don't know this basic, you are going to have a hard time. You are going to have a hard time in one of the highest weighted chapters in your paper, from where more than 40 questions have been asked in just 2024. So you better be clear with your basics. You better be clear with your fundamentals. Don't try to solve super tough questions. Don't try to understand concepts which are really bouncers. First, solidify your basics. First, solidify your fundamentals. You are not allowed to forget something so basic as Tn is Sn minus 1. Not allowed to forget at all. Non-negotiable, people. Must remember. Is it clear? Am I making sense, everyone? No discount here. Must know, must remember. On your fingertips, the concept should be crystal clear. Let's start calculating Tn. What is Sn? N into 2n square plus 9n plus 13 whole upon 6 minus Sn minus 1. So n minus 1, 2 times n minus 1 square, 9 times n minus 1 plus 13 whole upon 6. Can you calculate what is this? Can you? Tell me, can you calculate? 1 upon 6 to chalo will come outside. Can you calculate what this is? Huh? See, this is 2n cube minus 2 times n minus 1 cube plus 9n square minus 9 times n minus 1 square plus 13n minus 13 into n minus 1. This is what you have. This gives you 1 by 6, 2 common, n cube minus n minus 1 whole cube. Is it clear? Plus 9 common n square minus n minus 1 square plus 13 common n minus n plus 1. I am playing smart. I am trying to save my time. That is why I have clubbed the like expressions. So plus n minus n cancels out. You are just left with 13 in the end. What about here? A square minus b square. What is this? A square minus b square. A plus b into a minus b. So it's 2n minus 1. This is simply 2n minus 1. What about this? A cube minus b cube. A minus b, which is 1, into a square plus b square. 2ab? Yes or no? Yes or no? Aryan, Sara, everybody please quickly answer. Quick, quick, quick. A square plus b square plus ab. A cube minus b cube is a minus b into a square plus ab plus b square. So a square plus b square plus ab, because a minus b is 1 only. Ab means n into n minus 1. That's it. That's it. So you are left with 1 by 6. You have 2 times n square plus n minus 1 whole square plus n into n minus 1 plus 9 times you have what? 2n minus 1 plus 13. Anybody who solved it further? Tell me, what is this? This is n square minus n. And this is what? N minus 1 whole square. N square plus 1 minus 2n. So n square, n square, n square. 3n square minus 3n plus 1. 3n square minus 3n plus 1. Please check this. Everybody keep checking this. Now you open this up. 1 by 6. 6n square minus 6n plus 2 plus 18n minus 9 plus 13. So you have 6n square. This is gone. Minus 6n plus 18n. So plus 12n. And you have what? 2 minus 9 is minus 7 plus 13 plus 5. Please check this. 2 minus 9 is 7. Oh, 6 plus 6. So 6 comes out common. You're left with n square plus 2n plus 1. 6 cancels out. You're left with n plus 1 whole square. Pretty. This is cute. This is nice. We started with such a jumbo giant expression, and this is the beauty of algebra. If you are patient with it, if you are really composed while solving it, while computing these algebraic calculations, if you are pretty patient and resilient, focused, composed, then trust me, you will sail through these irritating calculations, and when you are correct in solving, you will reach the right expression. And that will give you so much of happiness, I can't even begin explaining. I can't begin explaining. It's so nice. It's so satisfying. It's so satisfying. Okay? Yes, everyone. Did you reach till here? N plus 1 whole square. Everybody, have you reached till this step? We have got our Tn. We have successfully got our Tn. Is that cool? Which is n plus 1 whole square. Now, what is the question? See, Tn is n plus 1 whole square. Now, you want summation 1 upon r under root tr. So, this is summation 1 upon r under root tr is r plus 1 whole square. So, this gives you simple r plus 1. This is so simple. This is a very simple telescopic series. Do you understand? Every minutest of concept which is important from algebra point of view will be covered in all the questions which I will share with you today. All you need to do is sit tight, stay focused, and keep learning everything which I'm teaching. Everything is superbly important. Superbly important. Tell me, Any problem? Any problem? What is this? 1 upon r minus 1 upon r plus 1. Very basic. You write it as difference of two consecutive terms. Yes, ma'am. No, ma'am. R going from 1 to n. Yes or no? Quickly tell me. But this is an infinite series. This is not from 1 to n. This is from 1 to infinity. So you will get what? 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3 plus 1 upon 3 minus 1 upon 4 plus 1 upon 4 and so on. Every consecutive term will get cancelled apart from 1. 1 is your final answer. Isn't this a brilliant question? Super brilliant question. Isn't this a superbly brilliant question? Such a nice question based upon this concept which I know many of you all did not remember. This is a superstar concept, guys. Superstar idea, everybody. How do you reach from Sn to Tn? Tn is Sn minus 1. The moment you apply this concept, you get the expression for Tn as n plus 1 whole square. Plug it in this series which you want to compute and eventually it turns into a telescopic series. Very basic one, very, very basic one. Something which we are very much familiar with. And get the answer is 1. Alrighty. Alrighty, everyone. Shall I move ahead? Comes next from the world of quadratic equations, a fantabulous question. This is a must do and let me tell you, it's a tricky question. Don't feel just because the chapter is quadratic, you are always going to get easy peasy questions which are low hanging fruits. No, the examiners now know that quadratic is a chapter whose roots are in your 10th grade and 9th grade. Right? It is one of the easiest chapters. Some of the subtopics get added in 11th grade, but majorly the concepts are clear from 9th and 10th grade itself. So now the level of quadratic is also rising slowly and gradually in your JEE Main exams. Many times it happens that student feels that this is a quadratic question. I will definitely ace it. I will complete it for sure. But when you start to attack it, you realize that, oh, it's just not striking. I don't know what to do. Somehow I'm not able to understand what is the next way ahead. What is the next step forward? And this is where your ego hurts. This is where you feel that, oh, such an easy chapter. I have mastered it thoroughly. I have solved it so nicely. Still, I'm not able to crack this question. So it's so difficult for you to accept defeat. You take it so personally that you are stuck on that same question for 7, 8, 9, 10, 11, 12, 15 minutes. Eventually, on the 16th minute, somehow some enlightenment happens and you're like, okay, let me leave this question and might as well focus on other questions which I can do, which I know how to solve. This is a big time waste, people. I want to give you this golden tip. Accept defeat very quickly. This is not a paper where how many questions you solve is important. It's important that you solve the right questions which are your strengths quickly, smartly and grab as many marks as you can. You have to see the entire paper as one single unit. No matter from where the marks are coming, let them come. Don't make this a rule that I have to earn the marks from quadratic questions only. No compulsion. From wherever you are getting marks, earn. Don't attach your ego. Don't be attached to any one question from your favorite chapter. It is going to be a big backfire. It will literally work against you very badly. Okay? Tell me, alpha plus 1 by alpha, very intelligent question this is, very intelligent. If you know how to solve this, I will be really impressed. This is a 99.8 percentile question. Very, very intelligent. Very, very intelligent. Anybody, any clue? I would love to read your comments on this. Anybody, any clue? Not a very easy question. As I said, it's tricky, but you won't even realize when this question actually ends. You won't even realize, and this question will end so quickly. You won't even realize. It's a very short and sweet question, but requires presence of mind. Requires presence of mind. Anybody? Anybody? Huh? Come on. You have two roots. The quadratic equation is x square minus 2 times a plus 1 into x plus a minus 3 equal to 0. This has two roots, guys. One is alpha plus 1 by alpha and one is 2 minus beta minus 1 by beta. Okay. The leading coefficient of this quadratic is 1. That means it's positive. So it's a positive leading coefficient. It has two distinct roots, distinct real roots. It has two distinct real roots. Because it has two distinct real roots, these two are the two distinct real roots. This means the discriminant is pakka positive. This is something which indirectly the question is telling us. The discriminant is pakka positive. That means the graph of this quadratic will look something like this. This is the first root, alpha plus 1 by alpha. This is second root, 2 minus beta minus 1 by beta. Alright, this is your quadratic. Okay, fine. What next? Sum of integral values of a is what the question asking. Okay, fine. I know alpha is positive. The moment I look at alpha plus 1 by alpha, I know as a matter of fact, this is a result. You can prove this using AMGM. This is greater than equal to 2. How many of you all know this? This is a fact, people. You have to remember it as a fact. It's actually a result. You can prove this using AMGM inequality, but remember this as a fact. The moment you see alpha plus 1 by alpha where alpha is positive, x plus 1 by x where x is positive, beta plus 1 by beta where beta is positive, y plus 1 by y where y is positive, all of this is having its minimum value as 2. The minimum value is 2. Similarly, beta is also positive. So, beta plus 1 by beta is also greater than equal to 2. Both these things are true, na? Alpha plus 1 by alpha is at least 2. Beta plus 1 by beta is again at least 2. Yup. This part, chalo, is logged. What about beta plus 1 by beta? That means minus beta minus 1 by beta is less than equal to minus 2. If you add 2, you get 2 minus beta minus 1 by beta is less than equal to 0. So these are your two roots, guys. These are your two roots. One root is greater than equal to 2. Other root is less than equal to 0. One root is greater than equal to 2. Other root is less than equal to 0. That means your roots actually will look like this. This is 2 minus beta minus 1 by beta and this is alpha plus 1 by alpha. Because it is greater than equal to 2 and this is less than equal to 0. Oh. So the positioning of 0 and 2 is something like this. My first root can be 0 or less than 0. My first root can be 0 or less than 0. My second root will be 2 or greater than 2. My first root will be 0 or less than 0 and my second root will be 2 or greater than 2. So to ensure such a situation, what is the condition which I should impose? Mathematical condition. What is the mathematical condition which I should impose? This is the question on location of roots, bache. This is what should strike you. This is the question on location of roots. My f of 0 will either be negative or it will be equal to 0. Arey baba, if my first root, this is my first root and this is, let's say, my second root, okay. My first root is less than 0 or equal to 0. That means f of 0 is either negative. You can see f of 0 is either negative or it is equal to 0 if it coincides with the first root, right? So it is less than equal to 0 and you have f of 2 to be what? Tell me, again less than equal to 0. If 2 coincides with the second root, f of 2 will be 0. If 2 is less than the second root, f of 2 will be negative, as you can see. Huh? What is f of 0 less than equal to 0? 0, 0, this is a minus 3 less than equal to 0, a less than equal to 3. And f of 2 means this is 4 minus 2 times 2 into 2, 4 times a plus 1. Plus a minus 3 is less than equal to 0. So this gives you 4 minus 4a minus 4 plus a minus 3. So plus 4 minus 4 is gone. Minus 4 plus 3 is minus 3a minus 3. Less than equal to 0. So 3a plus 3 is greater than or equal to 0. That means 3a is greater than or equal to minus 3 or a is greater than or equal to minus 1. So a is greater than or equal to minus 1 and a is less than or equal to 3. Can you see this? A is less than or equal to 3, a is greater than or equal to minus 1. That means a belongs to minus 1 comma 3. How many integral values of a are there in this interval? How many integral values of a are there in this interval? Minus 1, 0, 1, 2 and 3. There are 5 values. Can you imagine the beauty of this question? I mean, this question deserves a huge round of applause. Literally, this question deserves a huge round of applause. It's such an indirect question based upon the concept of location of roots. Such an indirect application of location of roots. This is exactly the question which happens to be a slippery area for majority of students in the paper. They don't realize that the question is actually easy. It's a small, tiny question which just involves your basic visualization skills. If the moment you visualize the quadratic polynomials graph, you know what to do next. The moment you visualize, you know what to do next. Moreover, one thing which played a very important role was the result that x plus 1 by x is at least 2 when x is positive. The moment you apply that result, again the question is a smooth sail. It's like walk in the park. It keeps on happening then automatically. And of course, here we have applied the concept of location of roots. Hello, Rambo. Is it okay? Wonderful, wonderful question. Must enter your notebook with a star on the side because you will forget this. You will forget this. Okay? Can I move ahead now? Everybody? Bahut badhiya. Rambo, perfect. I'm doing awesome. Come here. Oh my God. Very famous, very popular. One of the most repeated categories of questions in the paper. This is system of linear equations. System of linear equations, and let me tell you, this is a level up question based upon system of equations. If you can crack this, 99.99 percentile. This is A, this is B, this is C, and this is D. Please tell me. Tell me. Consider the following system of linear equations. The system is consistent if. Anyone? Anyone? X plus y plus 5z equal to 3. X plus 2y plus mz equal to 5. X plus 2y plus 4z equal to k. What do you think I should do? What do you think I should do? Rambo Light is saying option C. Rambo Light is saying option C. Okay, fine. Rambo Light is saying option C. C means m is equal to 4. Okay, I'll give you a hint. This is a multi-correct question. Multi-correct. Anyone? Wonderful, wonderful, wonderful question. Must do question, guys. If you really want to get those 4 marks, which you are bound to get from this question that will come in the paper from system of equations, you must solve this question. This question will clear all your doubts, all your confusions. Look at this. This is a non-homogeneous system for sure. This is a non-homogeneous system of equations for sure. For sure. Yes, it's a non-homogeneous system of equations. You want the system to be consistent. For the system to be consistent, del should be non-zero. Right? You know this, right? For system to be consistent, what do you need? My del should be non-zero. Del means determinant of coefficient matrix. So you get 1, 1, 5. You get 1, 2, m. You get 1, 2, 4. This should be non-zero. Please solve it. You get what? 8 minus 2m minus, this is 4 minus m plus 5 times, what do you get? 2 minus 2 is 0. Okay, fine. So 8 minus 2m minus 4 plus m is non-zero. So this is 4 minus m is non-zero, or m is not equal to 4. So my system will be consistent as long as m is not equal to 4. My system will be consistent as long as m is not equal to 4. So the system is consistent if m is not equal to 4. Okay, fine. Okay, fine. Is that all? Is that all? What about k? What about k? What about k? My system is consistent if m is not equal to 4. Pakka, that is true. Consistent means two things: unique solution and infinitely many solutions. What about k? This option though is wrong. For m not equal to 4, my system is consistent. My m is not allowed to be equal to 4. If m is 4, that means del is 0. Del is 0 means my system is not consistent. Yes or no? Please tell me quickly. Is that right, what I said? See, del equal to 0 means two things. Either you can have a no solution or infinitely many solutions. Okay, that depends upon del 1, del 2, del 3 as per Cramer's rule. Now, even when you have infinitely many solutions, even then you can have a consistent system. No, consistent means it should have at least one solution. So, when del is non-zero, you will have unique solution. Unique solution means consistent. That is why m not equal to 4 is definitely the right answer. But m equal to 4 might not be the wrong answer. Because m equal to 4 implies del is 0, and del is 0 has two answers. Either there are no solution or infinitely many solutions. If we end up getting infinitely many, then even this is correct. Because in this case, it will have a consistent system. Yes? So right now, I can't say m equal to 4 is wrong. I just know m equal to 4 implies del is 0. And m not equal to 4 implies del is non-zero, and therefore there is pakka unique solution. Unique solution means system is consistent. So A is correct. But what about BCD? What about BCD? Huh? What about BCD? Let's say if m is equal to 4, which means if del is equal to 0. But del not equal to 0, we have examined. Now, del equal to 0, we have to examine, because del equal to 0 also contains the possibility of infinitely many solutions, which again means the system is consistent. So, we have to consider this possibility. Del equal to 0 means m equal to 4. System becomes x plus y plus 5z equal to 3. X plus 2y plus mz means 4z equal to 5. Then x plus 2y plus 4z equal to k. Now, you know, as a matter of fact, the shortcut which I have taught you asks you to treat all these equations as the three planes. You can see these two planes are actually identical if 5 becomes equal to k. If k becomes equal to 5, then P2 and P3 actually become identical. And P1 has different direction ratios. P2, P3 have different direction ratios. That means P1 and P2. P2, P3 are same only, na? P1 and P2 are actually intersecting planes, intersecting at a line, and that line has infinitely many points. So there will be infinitely many solutions in this situation. If m is 4 and along with that k is 5, if m is 4 and along with that k is 5, then my planes P2 and P3 are actually 1, and my P1 is intersecting this, creating a line. Creating a line. Is it clear? And hence there are infinitely many solutions. But if k is not equal to 5, then P2 and P3 are parallel with a positive distance between them. If P2 and P3 are parallel with some positive distance between them, there is no solution. So in this case, there are infinitely many solutions, and in this case, there are no solutions. Is this clear? Is this clear? Let's go to the options. It says, what about k not equal to 5? There is no restriction upon m. There is no restriction upon m. If k is not equal to 5 and there is no restriction upon m, do you think this is the right answer? No. K is not equal to 5. If m is not equal to 0, then there is a unique solution. If m is equal to 0 and k is not equal to 5, if m is equal to 0, not m is equal to del. See, this is m is 4 and say this is m is not equal to 4. Two cases can be there over m, na? If m is not equal to 4, then unique solution. But if m is equal to 4 and k is not equal to 5, if m is 4 and k is not equal to 5, then to no solution. So I don't know whether m is 4 or not 4. If m is not equal to 4, then the system will be consistent along with k not equal to 5. But if m is 4 and k is not equal to 5, then no solution. So right now, just on the basis of k not equal to 5, I cannot conclude anything. No, I can't conclude anything. What about m equal to 4? Just m equal to 4. Just m equal to 4 will not suffice, na bachche? Because just m equal to 4 means del is 0. Along with that, if k is also 5, then the system will be consistent. If m is 4 but k is not equal to 5, system will have no solution. So only m equal to 4 is not enough for us to conclude the system is consistent. What about D? K is 5. Now k is 5 means over m there can be two restrictions. M not equal to 4, m equal to 4. If m is not equal to 4, I don't care what k is, this is going to have a unique solution. So consistent. And if m is equal to 4 and along with that k is 5, then to pakka infinitely many solutions. So whatever m is 4 or not equal to 4, just k equal to 5 will 100% imply that there is at least one solution. Either unique or infinitely many, but I am sure my system will be consistent. This is the deep level analysis which goes in this question, which is why this question is such a big must do. This question is such a big must do. This question actually clears all the basics regarding system of linear equations. The visualization part is clear. The revision of when do you get a unique solution, no solution, infinitely many solutions is clear. The shortcut is completely revised. Are you understanding? And the presence of mind which relates m and k is also very important. Such a brilliant question, yeah. This question, if you have understood, you've got correct 99.99 percentile for sure. For sure. 100%. Tell me. Is it okay? Is it okay, guys? Is this making sense, everybody? Is this making sense? All right. Can I go ahead to the next question? I hope this is hashtag HDCC, everybody. Completely clear, no doubt, no confusion. Perfecto. Let me show you the next question, which is a JEE Advanced PYQ. This is option A, this is option B, this is option C, and this is option D. From matrices and determinants, this question actually will give you a wonderful revision of very important concepts from matrices. I have picked this question to just help you revise all those concepts. I am not saying this question will land in your JEE Main exam, but some internal part of it, some intermediate part of it can definitely come as an individual question in the paper. This is such a good question, such a concept heavy question. There are some questions which actually help you revise a big chunk of the entire chapter. This is such a question. It's such a question. Should we start? You have to choose the incorrect option. Okay, let's start with the first one. M is a 2 cross 2 non-zero skew symmetric matrix. Okay, fine. I minus M into I plus M inverse, is it orthogonal or not? Starting with option A. M is a 2 cross 2. M is a 2, guys, please try. M is a 2 cross 2 skew symmetric matrix. It's a skew symmetric matrix, which implies M transpose is equal to minus M. I have to conclude that I minus M into I plus M whole inverse is orthogonal. When do you say a matrix is orthogonal? A is orthogonal when AA transpose is equal to I. Yes? Yes, this implies A is orthogonal. A is orthogonal. For an orthogonal matrix, inverse is equal to transpose. And for an orthogonal matrix, the determinant is always plus or minus 1. Yes? Is that cool? But how will you prove that this is orthogonal or not? I minus M into I plus M inverse. To show I minus M into I plus M inverse is orthogonal. Okay, let me start with making life easier for myself. Let me say I minus M is matrix A and I plus M is matrix B. Okay, just understand for a minute what is A transpose. This is I minus M transpose, which is I transpose minus M transpose. M transpose is minus M, so this is I plus M, but I plus M is B. Similarly, what is B transpose? This is I plus M whole transpose, which is I transpose plus M transpose. M transpose is minus M, so this is I minus M, which is A. So you are basically getting what? You are getting A transpose is B and you are getting B transpose is A. Okay, big piece of information. Now, I want to prove that A into B inverse is orthogonal. This is what I want to show. Na? A into B inverse is orthogonal. That means this matrix into its transpose should be equal to I. Yes or no? A transpose is I. That's when you say A is orthogonal. So AB inverse into transpose of AB inverse should be I. Let's calculate. This is AB inverse as it is, and here you get reversal law of transpose. B inverse transpose times A transpose. So what do you get? A, B inverse. Here you get what? B transpose whole inverse into A transpose. What next? This is very simple now. Na? I just told you. B transpose is A. So this is A inverse. And A transpose is B. Just imagine associative property. I can write this as A, B inverse, A inverse, B. But B inverse, A inverse is what? AB whole inverse. This is AB whole inverse and this is B. But you know what? AB is same as BA. Yes, people, AB is same as BA. A into B gives you what? I minus M into I plus M. And you compute BA, which is equal to I plus M into I minus M. They both are equal. Yes, they both are equal. So AB is same as BA. So you get A into BA inverse into B. What is BA inverse? A inverse, B inverse. Club these two, you get I. Club these two, you get I. I square is I. That's how brilliant this question is. Such a wonderful part A. Part A is saying the correct thing. The claim that part A is making is absolutely valid, that I minus M into I plus M is, I minus M into I plus M inverse is orthogonal. Yes, it's orthogonal because the product of the matrix into its transpose is equal to I. So the claim made by A is right. That is why option is wrong, because I want to choose the incorrect option. Very nice question, guys. Very, very, very rich question. Next it says A is done. So A is right, but as per the question, it's wrong. Because this is correct, not incorrect. If M is 3 cross 3, now M is 3 cross 3. M transpose into M is I. Determinant of M is 1. determinant of m minus I is non-zero where m is not equal to I. Answer. Is this true? Try to read the second part. No, first part is done. You can remember this as a result also, or you can prove it the way I have proved it. Very simple, very smart approach. Tell me about option B. Tell me about option B. What does it say? M is 3 cross 3 now. M transpose M is equal to I. M transpose M is equal to I. It says determinant of M is 1. Okay. Then determinant of m minus I is non-zero. To show determinant of m minus I is non-zero where m is not equal to I. I want to find determinant of m minus I. But here's a catch, na? Very simple. If I start with determinant of m minus I know I is nothing but m transpose into m. Yes or no? So this is like writing I into m minus m transpose into m. That's how it seems like writing. Yeah? So I can take out what? I minus m transpose into m. So this gives you determinant of I minus m transpose into determinant of m. Because determinant of product is product of individual determinant. Determinant of m I know is 1. So this is equal to determinant of I minus m transpose. I minus m transpose. But this is what? This is actually equal to I is same as I transpose. This is m transpose. So you get determinant of I minus m whole transpose. But determinant of transpose is same as determinant of the original matrix. So determinant of I minus m. Can you see this? I had determinant of I minus m transpose. I wrote I as I transpose. So I transpose minus m transpose gives me I minus m whole transpose. But determinant of A transpose is same as determinant of A. Can you see this? Determinant of m minus I is same as determinant of I minus m. Determinant of m minus I is equal to determinant of minus of m minus I. Now minus 1 will come out of the determinant 3 times with the power of 3. Minus 1 to the power of 3 determinant of m minus I. So what do you get? What do you get? Minus 1 to the power 3 is minus 1. So you get twice of this is 0 or determinant of m minus I is 0. Yes or no? It is 0. It is 0. It is 0. It's not non-zero. That means what B is saying is incorrect, and that is why this is the right option. If M is a 3 cross 3 matrix where M transpose M is equal to I and determinant of M is 1, then determinant of M minus I is the 0 where M is not equal to I. It is 0. It's not non-zero. It is 0. Is it clear? Is it clear? Let's come to option C. Now, option C requires a specific property to be cracked. If you don't know that property, you can never crack this question. Crack this C part. What does it say, guys? Understand carefully. M is a 3 cross 3 matrix. Let P be a non-singular matrix. Non-singular means determinant of P is non-zero or P is invertible. P is invertible. Any language can be used. Such that P inverse MP is a diagonal matrix. Then trace of P inverse M cube P is 134. What is the result? Do you know that? Do you know what is the result? Do you know? The result says if P inverse MP is a diagonal matrix, if P inverse MP is a diagonal matrix where M is known to you and P is invertible, that means it's non-singular or its determinant is non-zero, then, very important guys, trace of P inverse MP is equal to trace of M. Or trace of P inverse m to the power n P is equal to trace of m to the power n. And that is why, as per part C, trace of P inverse m cube P is equal to trace of m cube. That's it. This is the only thing you had to decode, that the question is asking you to compute trace of P inverse m cube P. All you need to compute is trace of m cube. All you need to compute is trace of m cube. All you need to compute is trace of m cube. Is this making sense? Is this making sense? Now you have m with you. You have m, you compute m square, you compute m cube. This is a legit, laborious mechanical work. You have m, you compute m square, multiply m with itself twice, then compute m cube, m square into m. Look at the diagonal entries and add all of them. Your answer will come out to be 134. So option C, the claim is right, and that is why the option is wrong. But is the result clear? Without the result, you can never ever crack the part C. Very important. See, nowadays when it comes to mathematics, the distinction between the level of questions in advanced and mains is not much. There is not much gap in the level of difficulty of the questions in advanced and in mains, especially when it comes to mathematics. And that is why these results, which generally students believe are important from advanced perspective, that is completely wrong now. The results you should know when you are due for your main exam as well. Any question, there are tons of questions. In fact, I will share the questions as well with you. There are tons of questions which have been asked in advanced, but they have also been repeatedly asked in your mains exam, especially in the last couple of years. There have been tons of advanced level questions which are very old advanced level questions, and they have been now, the trend is that they are being asked in the mains paper as well. So the results which generally students have tendency to believe that, okay, these results are only important from advanced perspective. No, they are important from mains perspective as well. Please remember this. Please remember this result. It's going to be really a big time saver for you. Questions like these which are there in part C straight away get cracked using this property. Very important. Makes the question very easy. Part D. M is a 3 cross 3 invertible matrix with real entries. M inverse is adjoint of M. What is then M cube is equal to M? Is that the conclusion? The question says, is that the conclusion? Let M be a 3 cross 3 invertible matrix, okay, with real entries. M inverse is adjoint of M. M inverse is adjoint of M. M cube is equal to M. What do you think? What is adjoint of M? Anybody? I have already told you the properties of adjoint of a matrix are topmost priority for NTA when it comes to matrices and determinants. Topmost priority. What is the answer for adjoint of a matrix? Adjoint of M. This is determinant of M to the power n minus 2 times M. Here n is equal to 3. It's a 3 cross 3 matrix. So determinant of M to the power 3 minus 2 is 1 times M. This is M inverse. Huh? Yes ma'am, no ma'am. Yes ma'am, no ma'am. Now what you do, this is to chalo you have. Now what you do, because you have M inverse is equal to adjoint of M, why don't you take determinant both sides? This gives you 1 upon determinant of M. And what is adjoint of M determinant? This is determinant of M to the power n minus 1 whole square. N is 3. 3 minus 1 is 2. 2 square is 4. So this is determinant of M to the power 4. So you get what? Determinant of M to the power 5 is 1, or determinant of M is 1. Yes or no? Determinant of M is 1. Plug it back here. What do you get? M inverse is equal to M. If M inverse is M, multiply M both sides, you get M square is equal to I. Multiply M again both sides, you get M cube is equal to M. You get M cube is equal to M, and that is what you wanted. So this means the claim that option D is making is right, and that is why it's the wrong option. This is also wrong because actually it's right. This is right because actually it's wrong. And this is wrong because actually it's right. Okay. So more than choose the incorrect option or correct option, I want you to understand the flow and the learning that you've got from every part. Every part over here is like one single question. That is why I deliberately picked up this question to explain to you some of the most important chunks of matrices and determinants which should not go out of notice when you are preparing or revising or studying MND. MND has to be studied very, very perfectly, and all these concepts which got revised from these four options are utmost important. Is this clear? Hi Akash, is this question hashtag HDCC guys? 100% clear, no confusion, no iota of doubt whatsoever, because I am moving on to the next one now. I am moving on to the next one again from your favorite chapter. Let's see if you're able to crack this or not, is this question. Again from the world of matrices and determinants. Let's see if you can crack this question. Trace of AB minus BA whole cube upon determinant of AB minus BA. Very nice. Ultimate. It's an ultimate question. It is an ultimate question. And if you know how to crack it, oh my God, you've crossed the 99 percentile barrier already, because this is a 99.99 percentiler question. And questions like these are bound to appear in your JEE Main because they might look new, but they are actually old. I told you I have mixed a couple of JEE Main questions together to give you a new question, but actually it's a mix of 2 or 3 JEE Main questions only, PYQs only. It might just look different. So you can't say that this question will not appear in the paper. But the concept that it's based upon is the beauty of this question. It's the beauty of this question. What is the value of trace of AB minus BA whole cube whole upon determinant of AB minus BA? Okay. Is it clear? Akash, I think you should subscribe to the channel because Monday is chemistry, Wednesday is mathematics, Friday is physics. That's the trend right now. But please stay subscribed for any change in the schedule or any new series that we are coming up, any session which is scheduled. I don't want it to go out of your notice. So stay subscribed to the channel and also turn on the notifications by hitting the notification bell. Mind-blowing question. Are pehle first crack this, no? What is the concept you feel will be applied here? Now AB minus B again and again it's popping up. So let me take AB minus BA as M. So this is M cube and this is determinant of M. This is M cube, trace of M cube upon determinant of M. Trace of M cube upon determinant of M. M is what? AB minus B. Let M be AB minus BA for my convenience. What next? What next? You have M cube in picture. You have determinant of M in picture. In fact, you have trace of M cube in picture. Is something striking? Are some bells ringing here and there? Is something knocking the doors of your memory? Huh? Trace of M cube upon determinant of M. Come on, guys. Trace is there, determinant is there. M is a 3 cross 3 matrix because AB minus BA is 3 cross 3. This is what comes into picture. People, this is what is shouting out loud to be used. Characteristic equation for a 3 cross 3 matrix. What does it say? M is a 3 cross 3 matrix. m cube minus trace of m into m square plus sum of cofactors of diagonal elements into m minus determinant of m times I is 0, null. Absolutely correct, Kirtika. This is your characteristic equation for a 3 cross 3 matrix. Now tell me, I will deliberately write this sum of cofactors of diagonal elements as S. Just denoting, again, I don't want to write this paragraph. So this is equal to S. Okay, fine. What about trace of M? Trace of M means trace of AB minus BA. And I told you in my one shot of M and D that actually this is equal to trace of AB minus trace of BA. Both AB and BA actually have the same trace. I am not saying AB and BA are always equal. No, you know, in general, multiplication of matrices is not commutative. AB in general is not equal to BA. But the sum of diagonal entries of both these matrices is always equal. No matter what is the order of the matrix, as long as AB and BA is well defined, if you add their diagonal entries and compute the trace, it will come out to be equal. This is a 0. Trace of AB is always equal to trace of BA, guys. Please remember this. Very, very, very important result. Like this, it can just come by anywhere in between in one single slight small step, and it can be a game changer step. Trace of AB minus trace of BA will be 0 because they both are equal. Both these quantities are equal. Again, I am not saying AB and BA are identical. No. In general, matrix multiplication is not commutative. But the sum of diagonal entries of both these matrices AB and BA is always the same. That is why the difference is 0. Okay. So this is 0. What are you getting? M cube minus 0 times m square is just 0. M cube plus sum into m minus determinant of m times I is null. What do you think I should do next? See, m cube is equal to determinant of m times I minus sum into m. So trace of m cube, that's what I want, na? Trace of m cube I want upon determinant of m I want. So trace of m cube is trace of determinant of m times I minus trace of sm. Now this is very interesting. Determinant of m is a constant. So that comes out. You're left with trace of the identity matrix. Minus s also comes out. It's sum of cofactors of diagonal elements. Again, it's a constant. So trace of m is left behind. Yes or no? Trace of I, 3 cross 3 matrix. This is 3. So this gives you 3 times determinant of m. And trace of m we just calculated is 0. So this is 0. So you are getting trace of m cube upon determinant of m bache is equal to 3. This is what you wanted, na? Arey, this is what you wanted. Look at the question. It's a fantastic question, people. Literally a 99.99 percentile question, and in a very subtle way, in a very indirect way, characteristic equation is coming into action. It's not shouting out loud the top of its voice. It's a characteristic equation question, but indirectly it's just popping in from somewhere. And if you use this, the question can be solved in a single page. But if you don't use this, literally, I am sure you will leave this question. Because there is no other easy way to attack this. There's no other easy way to attack this. Now, I have already shared with you questions which are very easily identifiable as questions based upon characteristic equation. But this is a question different from it. This is not very easily classified as a question on characteristic equation. But it is. And you saw why, you saw how. How it made life so simple for us. And the clue, the hint was you had trace, you had determinant, both in the same expression. You had a 3 cross 3 matrix, not a 5 cross 5 matrix. You had a 3 cross 3 matrix for which you know the characteristic equation. For a 2 cross 2 also you know. If m was 2 cross 2, you had m square minus trace of m times m plus determinant of m times I equal to null. This is a 2 cross 2 matrix characteristic equation. So both these characteristic equations you should know on your fingertips. Yes, you are right, Kirtika. Trace of AB is always same as trace of BA. Okay, Akash? Is this question completely clear, guys? I hope there is no confusion at all. Very important. These are actually rank decider questions. Now, these are not very lengthy questions if you actually see, but they are still rank decider questions because the concept which gets applied, the approach, the methodology, that doesn't click so easily. So if somebody has exposed himself or herself to these type of questions, only that person, that student will feel comfortable to crack this question in the paper. Otherwise, the moment a student who has never seen this question sees this question in the paper, he will get completely stressed. He won't be able to gather confidence to attack this question. Forget about cracking it. Not even the courage to attempt. That is for sure. And that is why increase your exposure, people. I am not bringing questions which are new and bouncer. I am bringing questions which are new, multi-conceptual, blend of PYQs, but doable. Because right now we have to learn to solve questions which are doable more and more. We don't have to, expose ourselves to questions which remind us of our weaknesses. Because this is the time when you have to strengthen your strengths. When you have to solidify your strengths. When we have to increase the number of questions which is doable for us, which is familiar to us, which is comfortable to us. Right? Okay? Alrighty then. Come to this question, guys. Come to this question. What do you think is going to be the idea to crack this? Now here there is a catch again, a very conceptual catch. It says AB is equal to BA. Okay, that means A and B are commutative. A cube is equal to B to the power 6. But you can't take cube root both sides because then A will be equal to B square and that is not allowed. The condition is given to you, you can't take cube root both sides. What is the value of determinant of A square plus B to the power 4 plus AB square? Do you know, the question looks very intimidating. It looks a bit scary, but it's actually very easy. It is such an easy question, I can't even begin to explain. It's a very easy question. Very easy question. Very easy. You know why? Because here you are given A cube is equal to B to the power 6. This is like A cube minus B square whole cube is 0. Tell me one thing, can you apply the identity of A cube minus B cube? I have told you all the algebraic identities get valid in the world of matrices when your matrices are commutative. If the matrix multiplication is not commutative, then your algebraic identities do not get activated in the world of matrices. If AB is equal to BA, it is but obvious that AB square is equal to B square A. If A and B are commutative, any power of A into any power of B is also commutative. So if AB square is commutative, then A cube minus B square cube, I can open up using an identity, which is A minus B, A square plus B square square, that means B to the power 4 plus AB, which is AB square. Now A is given not equal to B square, that means this is not null. This matrix can be null or non-null. It can be null or non-null because it's not a compulsion that if product of two matrices is null, at least one of them has to be null. There is no compulsion. I have shared with you in my one shot that you have two non-null matrices which on being multiplied are giving you a null matrix. But one conclusion which always holds valid. If product of two square matrices is null, both of them have to be singular. I don't care about they are null or not, but they have to be singular. Their determinant has to be 0. So product of these two matrices is null. Out of which this is pakka non-null, this can be null or non-null. But I know both of them are square matrices. That means determinant of A minus B square will be 0 and determinant of A square plus B square plus AB square will be 0. You wanted the determinant of this matrix. You have got it. It's 0, everybody. The question is done and dusted. Please remember this. Whenever product of two matrices is null, it does not necessarily imply that at least one of them or both of them have to be null. Because you have examples, plethora of examples where product of two non-null matrices is coming out to be null. But if you have product of two matrices which is null and both are square or at least one of them is square, then that square matrix will be singular. If both are square, both will be singular. I don't care about them being null or non-null. If they are null, as it is, the determinant will be 0. If they are non-null, then also the determinant is 0. So, if the product of two matrices is null, if both of them are square, both will be singular. If any one of them is square, that one will be singular. That is pakka. That is for sure. Please note this down. That is a very simple fact, a very simple basic property based upon which this question, which looked so intimidating and looked so scary, looked so fearful, is cracked within a minute. It didn't even take a minute. Yes, ma'am? No, ma'am? Okay? This question will blow your mind, guys. Please take a look. Take a careful look, take a very good read at this question and tell me how will you crack it. How do you even plan to crack it? How do you even plan to crack it? Quick. The number of permutations x1, x2, x3, x4, x5 of numbers 1, 2, 3, 4, 5 such that the sum of 5 products is divisible by 3. I'll take one case and show you what is the answer. The remaining cases are completely similar. You want the number of permutations x1, x2, x3, x4, x5 of the numbers 1, 2, 3, 4, 5 such that the sum of 5 products, this is divisible by 3. Sum of all these 5 products is divisible by 3. Tell me. It's not saying x1 is 1 only, x2 is 2 only, x3 is 3 only. It's just saying x1, x2, x3, x4, x5 is representing 1, 2, 3, 4, 5. How will you attack? Come on, start. It's a very, very nice question, yaar. Very nice question. Must do. And it's easy. See, what do you have? x1, x2, x3. Next you have x2, x3, x4, x3, x4, x5, x4, x5, x1, x5, x1 and x2. Please realize, guys, please realize, if I take let, I am saying let, see what I am letting, let x3 be equal to 3. Why am I letting this? What is the advantage? You will understand. Let me explain first. Let x3 is equal to 3. If x3 is 3, this is a multiple of 3. This is a multiple of 3. This is a multiple of 3. So, all of this is divisible by 3. This part is sorted. What about this part? What about this part? This part says x4, x5, x1, x1, x5, x2. So, basically x1, x5 is common. Inside you are left with x4 plus x2. You want this to be divisible by 3. When will it be divisible by 3? Tell me. When will it be divisible by 3? Huh? What is this? This is x1, x5 and inside you have x2 plus x4. When will it be divisible by 3, Baba? You know, na, x3 has taken the value 3. Now you are left with 1, 2, 4 and 5. if this is 1 and this is 2, 3 is taken, you can't take 3 now, 1, 2, 4 and 5. If x2 is 1, x4 is 2, then 2 plus 1 will give you 3. 2 plus 1 will give you 3. In that case, x1 can be 4, x5 can be 5 or vice versa. If x2 is 1, please understand, if x2 I fixed to be 1, x4 I fixed to be 2. This I am fixing, this I am fixing. The sum inside the bracket is becoming 3. Okay, outside I have still 2 unknown quantities, x1 and x5, which can take the values 4 and 5, one by one, chance by chance, I don't care. So corresponding to x2 1 and x4 2, I have 2 answers. Getting my point? When x2 is 2, x4 is 1, again I have 2 answers, 4 5 and 5 4. So 2 answers here, 2 answers here. Are you getting my point? Are you getting my point? Now 2 plus 1 will give me 3. Apart from that, see, 2 plus 1 will give me 3. Apart from that, what else will give me 3? 5 plus 1 will give me 3. Let's say x2 is 5, x4 is 1. x2 is 5, x4 is 1. I am left with 2 and 4. So x1 is 2, x5 is 4, or this is 4, this is 2. Again, 2 numbers. Or I fix this as 1 and this as 5. Again, 2, 4, 4, 2, 2 numbers. Can you see this? It's going to go brilliantly. Just the bracket of x2 plus x4, you have to make it divisible by 3. So bracket of x2 plus x4 can be 1 plus 2, 3, or 5 plus 1, 6, or what else? 4 plus 2, 6 also can be there, na? I fix this to be 4, fix this to be 2, I'm left with 1 and 5. So 1, 5, 5, 1, again 2. Or fix this to be 2, fix this to be 4, again 1, 5, 5, 1. So beautiful. So beautiful. Okay, what else? 5, 4 and 4, 5. Sum will be 9. 9 is divisible by 3. So fix this to be 5, fix this to be 4. Here you are left with what? 1 and 2. 2 and 1. Or fix this to be 4, fix this to be 5. Again 1 and 2, 2 and 1. 2 numbers here, 2 numbers here. Did you see this? Isn't this mind-boggling? Isn't this brilliant? I wanted to make this expression divisible by 3. I looked at its pattern. Can you see this? I looked at its pattern. It's like x1 into x5 multiplied with x2 plus x4. 3 is already taken by x3. I am left with 1, 2, 4, 5, which can be taken by x1, x5, x2 and x4. So how will I assign so that my expression is divisible by 3? I am making the sum inside the bracket as 3, then 6, again 6 and then 9. That's it, I am exhausted. I am exhausted with all possibilities. 2 plus 2, 4 plus 2, 6 plus 2, 8, 10, 12, 16, 18. 16, okay. Add all the 2's. How many? 16. If x3 is 3, if x3 takes the value 3, then 16 numbers which are divisible by 3, or 16 numbers, nahin, 16 ways in which this entire sum of the product of 5 quantities is divisible by 3. Similarly, if x1 is 3, then also 16 ways, you can check. If x1 comes out to be 3, everyone, if x1 is 3, then this and this will be already divisible. I just need to work upon making this divisible by 3, which will again happen in the same format, because you can see x3 and x4 will come out common. Inside you'll have x2 plus x5. You will perform the same story and you will get 16 cases here as well. So if x3 was 3, you are getting 16 ways. If x1 is 3, 16 ways. If x2 is 3, again 16 ways. If x4 is 3, again 16 ways. If x5 is 3, bache, again 16 ways. So 16 into 5. 16 plus 16 plus 16 5 times 80 is the final answer. I kid you not, such a brilliant question. Did you understand this? It's not something which is very easy or straightforward. This is a very new category of question, but it's a must do because now the level is going up, everybody. The type of questions or variety of questions or the difficulty level of the questions which students are getting familiar with and comfortable with is really high. So you can't expect me to spoon feed you, especially when it comes to mathematics, because mathematics determines the overall difficulty of the paper. Chemistry and physics as it is are coming pretty relatively easier. Always, like from last couple of years, if you see, chemistry and physics have always helped students to score marks. Math is something which determines your rank. Math is something which overall takes your performance up or down. So that is why you can't expect me to spoon feed you when it comes to question practice of either algebra or calculus or conics tomorrow or coordinate geometry, whatever is it. You can't expect that, right? You just can't. Cool? So please embrace the difficulty level or the newness of the question which is coming before you. If the question seems new to you, foreign to you, take a moment to absorb what it's saying, because the questions here are all doable. These are not the questions which I would recommend you to leave in the paper. This is just one case that you have to perform, rest everything is completely photocopy. But how to perform this one case, this methodology itself should be known to you in the first place. If it's not known to you, if you're not aware how to solve this question, if you've never seen such a question, how can you expect to crack it in the paper? You can never crack it in the paper. So you have to expose yourself to this method, to this variety of question, so that over there in the examination hall, it doesn't seem a surprise to you. Is it okay? Everybody, we are on the same page, right? Hashtag HDCC, everybody. Let's go to the next question. Very, very important, very interesting. Based upon, again, a supremely high weightage concept from PNC. 5 balls are to be placed in 3 boxes. Each can hold all the 5 balls. The number of ways in which we can place the balls so that no box remains empty if balls are different but boxes are identical. This is where majority students get confused. You have 5 balls. Balls are different. B1, B2, B3, B4, B5. You are saying no box remains empty. That means at least one ball should go in every box. Now there are 3 types of questions which can be framed here. One question is, balls are distinct, boxes are also distinct. So you have box 1, box 2 and box 3. Let's say this is A, let's say this is B, let's say this is C. So distinct balls, distinct boxes. What is the case? Distinct balls, distinct boxes. This is the case. Distinct balls, distinct boxes. 10. Naman is saying 10. We are discussing 3 questions from within this question only. Question is saying boxes are identical. I am saying what if the boxes were also distinct? And you wanted to distribute 5 balls among these 3 boxes such that no box remains empty. This requires the concept of grouping and distribution. You have to distribute 5 chocolates among 3 distinct kids. Each kid should get at least 1. So 3, 4, 5, 1, 2, 3, 4, 5. Grouping and distribution. Your answer would have been 5 factorial upon 3 factorial, 1 factorial, 1 factorial into 2 factorial, because 1 factorial is being repeated twice, or 5 factorial plus 2 factorial, 2 factorial, 1 factorial, again 2 factorial being repeated twice, so into 2 factorial. Once you have done the grouping, then you distribute among the 3 children in 3 factorial ways. This would have been your answer. But what if the boxes are identical? Tell me now, what if the boxes are identical? If balls are distinct and boxes identical. What do you do in such a case? You have B1, B2, B3, B4 and B5 and the 3 boxes are identical. Again in this case, you will distribute 5 chocolates in 3 groups as 2, 2, 1 and 3, 1, 1. The groupings can happen in how many ways? 5 factorial upon 2 factorial square into 1 factorial into 2 factorial plus 5 factorial upon 3 factorial 1 factorial square into 2 factorial. Once you have divided your 5 balls into 3 groups, now you are not distributing these 3 groups which are like 3 entities among 3 people because these 3 are like identical people, identical boxes. 3 distinct items among identical boxes. The distribution can happen in only one way because there is no distinction in the boxes. You have 3 distinct groups. One has 2 members, one has 2 members, one has 2 items, one has 2 items, one has 1 item. Or one has 3 items, one has 1 item, one has 1 item. Basically, you have 3 groups. You divided 5 objects into 3 groups. These are like 3 entities to be arranged in 3 boxes. But all these 3 boxes are identical. Right? So the arrangement cannot happen in 3 factorial ways this time. It will happen only in one way. Your answer is what? Your answer is what, guys? 5 factorial common. This is 1 upon 4 into 2, 8. And this is 1 upon 3, 6 into 2, 12. Huh? Are you using beggar's method? You're not using beggar's method, na? This is 25. This is your answer for the current question. This is your answer for the current question. But if you say balls are same and boxes distinct, this is where Naman is correct. The beggar's method will come into picture. Balls are same, boxes distinct. It's like 5 identical balls to be distributed among 3 boxes. It's like 5 identical chocolates to be distributed among 3 kids, such that each kid gets at least 1. The formula is n minus 1 c r minus 1. So 5 identical balls to be distributed among 3 boxes. It's like x1 plus x2 plus x3 equal to 5, where xi is at least 1. So your r is 3 and your n is 5. Number of positive integral solutions of this equation is 4c2, which is 6. Yes or no? If it would have been non-negative integral solutions, that means 0 balls in a box is also allowed, then my answer would have been n plus r minus 1 cr minus 1. That means what? N plus r minus 1 cr minus 1. So 5 plus 3 minus 1 c, 3 minus 1, 7 c2. That would have been the answer in case of empty boxes allowed. Right now, empty boxes are not allowed. Is this clear, everybody? We are not going to use beggar's method in this question. This question is actually this. This is the answer of the question. 25 is the right answer. This is just another case I was explaining. What if the boxes were distinct? Then it involves grouping and distribution. If balls are distinct, boxes are same, only grouping, no distribution. Or distribution is only one way. Say it anyway. Either you say there is no distribution or you say distribution can happen only in one way because boxes are identical. If balls are same, boxes distinct, chocolates same, children distinct, you use your non-negative integral solutions or positive integral solutions formula, the beggar's method. Identical items to be distributed among distinct people. Is that clear, guys? Through one question, I've explained you the entire concept of what all type of questions you can get in the paper from here. Is that making sense? Is that making sense? Yes? Can I move ahead? Comes this question which is going to blow your mind away. This will blow your mind away. See, when you expose yourself to different types of questions, what happens is in the paper, the first few questions that you choose now, that is primarily very important. Very important. Because if first 4 or 5 questions that you have chosen, you have been able to successfully solve them, get the correct answers, what happens is you get a boost of motivation. Literally, there is a very big dopamine rush in the body. Your good hormones are on a high. You feel very confident, very high on self-belief, completely motivated, and your momentum is bang on perfect. Otherwise, you would have been scared of whatever questions. Now you are ready to attack them with the correct mindset, and the chances of you being able to solve them correctly also increase drastically. That is why the first few questions you have to select very wisely and very smartly. Always in the paper, try to capture the low-hanging fruits first. Because every question is capable to give you 4 marks, na? Why are you interested in solving questions which are lengthy first? Every question is giving you 4 marks. So first, attack the easier questions or the easiest questions and earn as many marks as you can. Once you get those easy 16, 20, 24 marks, just imagine the confidence that you feel. Just imagine how secured you feel. You're like, now I have 20, 24 marks in my pocket. I just need another 20 marks, 20, 24 marks, and I will be done. I just need to crack 6, 7 more questions and I am done for today for mathematics. Just 6, 7 more questions. This itself starts seeming very realistic and very attainable. And also because so much big pool of marks you have already earned, it gives a boost of confidence. Literally, you feel so motivated and charged that now you are even more ready to attack these tougher questions which otherwise would have intimidated you, but now you're like, I have it in me to crack them. The attitude changes completely. When the attitude changes, obviously your approach changes. Your mind starts working in favor of you, not against you. It starts giving you ideas, it starts recollecting concepts which can be used to crack that tougher question. Because you are motivated, you are happy. Are you understanding? So use this psychological tactic. This is a very big psychological tactic. Use this. First, you catch hold of the easier questions, get that rush of dopamine, feel that feel-good factor, okay, that goodness which is there in your head, feel it. Then try it out for yourself in the mock test, how easily you approach the tougher questions which are left behind now, left for you to attempt. You will be more in josh and in charge and in completely pump to attack them, and you will be able to crack them. The chances of you being able to crack them will drastically increase. Okay? Tell me quickly, what is the way to crack this question? Number of positive integral solutions of, now till this time we were talking about equality. Positive integral solutions of an equation, non-negative integral solutions of an equation. This is an inequation. You have x plus y plus z less than 10. Arey Baba, x is positive, y is positive, z is positive. X, y, z are positive. X, y, z are positive. Yes or no? Positive. That means minimum value of x plus y plus z can be 3 and maximum value of x plus y plus z can be 9 because it's strictly less than 10. And I want integral solutions, so they can only take natural numbers. In order to convert this into an equation, I will do this. X plus y plus z plus w is equal to 10. Obviously, if this is equal to 3, which is its minimum value, my w will take the value 7. If this is 4, w will be 6. If this is 5, w will be 5. If this is 6, w will be 4. If this is 7, w will be 3. If this is 8, w will be 2. And if this is 9, which is its maximum value, w will be 1. That means w is also at least 1. So x, y, z and w are at least 1. So now what I need is positive integral solutions of this equation. Here n is 10, here r is 4. You get what? N minus 1 c r minus 1? 9c3. 9C3. Did you understand? This is n minus 1 CR minus 1. Because here you have converted an inequation into an equation. Very smartly, very, very new type of a question which actually is old. Eventually it's becoming what? It's asking you what is the number of positive integral solutions of this equation, which I know is n minus 1 CR minus 1. But we reached the equation stage from the inequation stage after analysis. Okay. Also it says positive integral solutions of this x, y, z equal to 480. This is new. This is new. Tell me, what is 480's prime factorization? 2 into 2 into 2 into 2 into 2 into 3 into 5. Yes. 2 to the power 5, 3, 5. Okay. Now listen to me. You want positive integral solutions of x, y, z equal to 480, right? This is the prime factorization of 480. Now I can, one of the possibilities, take x to be 32, take y to be 3 and take z to be 5. One of the possibility of x into y into z to give you 480 is take x to be 32, y to be 3, z to be 5. One of the possibilities. Yes. What are other possibilities? How do you reach to this possibility? How do you reach to this possibility? Huh? Understand, guys, this is a very new type of a question. Actually old but new for you because you are not habitual of computing positive integral solutions for a product xyz. You are habitual of computing positive integral solutions for the sum of xyz equal to n, right? Not product of xyz. So what you do is, you have 5 2's, understand? You have 5 2's to distribute, 5 identical 2's to distribute among x, y and z. You have 5 identical 2's to distribute among x, y and z, which are 3 distinct entities. So 5 identical 2's to distribute among 3 boxes, 3 distinct boxes. What do you do? 5 identical 2's to distribute among 3 boxes, and it is allowed that empty boxes are allowed. It can happen that none of the 2's go to x, all 2's go to y, none of the 2's go to z. That's fine. If all 2's go to y, that means y is assigned 32. X, let's say, gets assigned 3, z assigned 5. So the product gives you 480. So it is okay if empty boxes are also allowed. It is okay. That means what do I need? I want non-negative integral solutions of this equation. 5 identical 2's to be distributed among 3 boxes x, y, z. That means I want x plus y plus z equal to 5. Or not x plus y plus z, treated as x1 plus x2 plus x3 equal to 5, where x1, x2, x3 are non-negative. In how many ways? Tell me. N plus r minus 1 cr minus 1. This is 7c2. So I can distribute these 5 2's among x, y, z in 7c2 ways. Next is 3. 3 has 3 options. It can go to either x. There is only one 3, na? There is only one 3. It can go to x, or it can go to y, or it can go to z. So 3 has 3 ways to get distributed. Next is 5. There is only one 5. Only one 5. 5 has again 3 options. It can go to x, or it can go to y, or it can go to z. So there are again 3 ways. This is your answer for Q. Did you understand? There were 5 identical 2's to be distributed among x, y, z. I used this approach, the beggar's method. But there was only one 3. This 3 can go to x, or go to y, or go to z. It has 3 choices. There was only one 5. 5 can go to either x, or y, or z. It has 3 choices. This is your answer for Q. And this is your answer for P. Is this clear? Is this clear? This is 21 into 9. 189. And this is your 84. That's it. Do you understand? Absolutely correct, Naman. 4 by 9 is the right answer. P by Q. 84 by 189. 4 by 9 is the right answer. Is this understood? This part is very important. Is this clear? This is at least something which might be familiar to you, but for children who don't know, inequality converted to an equality and then apply Beggar's method. Please take a note. And you have an equation which involves product of x, y, z, not sum. And then you are applying how smartly in between you are applying Beggar's method. Please take a note. Not a very regular question, guys. I want you to please take a note of this. Is this clear? Very important. One of the most important categories of questions in today's session. One of the most important categories of questions. All right. Let's come to the next one quickly. It says summation NCR upon R plus 1. Looks familiar. Summation minus 1 to the power R plus 1 NCR upon R plus 1. This is 1. Please change this to 1. It's not 0. Okay. What should we do? If this value is 5, what do you think you should do? How do you resolve this expression? NCR upon R plus 1. Can you see this? Does this look familiar? It should look familiar, people. It should look familiar. NCR upon R plus 1. Do you remember? N plus 1 CR plus 1 is equal to N plus 1 upon R plus 1 into NCR. So, NCR upon R plus 1 is equal to N plus 1 CR plus 1 upon N plus 1. This is the result which is being aggressively used here. How will you write this? You will write it as summation NCR upon R plus 1 is N plus 1 CR plus 1 upon N plus 1. So, 1 upon N plus 1 goes out. Similarly, in the denominator, what do you have? Summation minus 1 to the power R plus 1. NCR upon R plus 1 is N plus 1 CR plus 1 and then upon N plus 1. Cancels out. Cancels out. What next? This is R going from 0 to N, but this is R going from 1 to N. Let's open this up. R is 0. So you get N plus 1 C1 plus N plus 1 C2 plus N plus 1 C3 plus and so on N plus 1 C N plus 1. What about the bottom, the denominator? Minus 1 to the power 2 is a plus 1. So you get N plus 1 C2 minus N plus 1 C3 plus N plus 1 C4 minus N plus 1 C5 and so on. Then you have minus 1 to the power N plus 1, N plus 1 C, N plus 1. Okay. How do you plan to resolve this? Huh? The numerator is very easy. Numerator is very easy. I just need N plus 1 C0 to add and N plus 1 C0 to subtract. N plus 1 C0 plus N plus 1 C1 and so on till N plus 1 C, N plus 1 is 2 to the power N plus 1, na? Minus 1. This is your numerator. This is 1. From here to here, you know the result. This is 2 to the power N plus 1. So this much part is sorted, I guess. Sum of all binomial coefficients of x plus y to the power N plus 1 is 2 to the power N plus 1 minus 1. What about the denominator? There is a problem in the denominator. It's starting with N plus 1 C2. Okay, I know if I alternative with an alternate plus minus sign, if I add and subtract the binomial coefficients, the answer is 0. Do you know this or not? NC0 minus NC1 plus NC2 minus NC3 and so on is 0. So with an alternate plus minus sign, when you consider the binomial coefficients, the answer is 0. Here you have alternate plus minus sign in the denominator, but all the binomial coefficients are not written. So let me write. This is plus N plus 1 C2. So minus N plus 1 C1. And then here it is plus N plus 1 C0. Can you see this? Can you see this? Similarly, I will subtract N plus 1 C0 and add N plus 1 C1. Can you see this? So from N plus 1 C0 till here, my answer is 0. This part is equal to 0. All I am left with is this part. Minus of N plus 1, this is, let's write, minus 1 plus N plus 1. This gets cancelled. You are left with 2 to the power n plus 1 minus 1 upon n. Do you understand this? It's a fantastic question, people. You have to realize what I'm doing. The numerator was resembling what? Sum of all binomial coefficients. So the answer was 2 to the power n plus 1. Minus 1 because I had to balance it out. Denominator is suggesting what? This result. Alternate plus minus sign between binomial coefficients, answer is 0. My series was starting with n plus 1 C2. I added n plus 1 C0, subtracted n plus 1 C1, and to balance it out, I subtracted n plus 1 C0, added n plus 1 C1. This entire series which I have done a zigzag upon is 0. Only this much part is left in the denominator, which is n. Please tell me if there is any confusion, any doubt, guys. Any confusion, any doubt, stop me right now. Stop me right now. This is your series which is equal to 5. So you are getting 2 to the power n plus 1 minus 1 upon n is equal to 5. That means this is equal to 5n. When you use your hit and trial method, n comes out to be 3. N comes out to be 3. Just use your hit and trial method and n will come out to be 3 very easily. Very, very easily. Is that okay? Is that okay? Is that okay? Is the question understood, guys? This one very, very clear. The value of n is 3. Right towards the end, just apply hit and trial. 1, put n equal to 1, n equal to 2, n equal to 3. 3 will satisfy. Okay? Time for this question, everyone. You are supposed to tell me what is the sum of all rational terms in this expansion. Now, the beauty of this question is, generally you know how to compute rational terms, irrational terms, integral terms in a binomial expansion, not in a multinomial expansion. This time I have asked you a question, similar type of question, but not with binomial, with multinomial expansion. How will you crack this? Multinomial. Write the general term. Write the general term. What is this? 10 factorial upon p factorial, q factorial, r factorial. 2 to the power 1 by 2 raised to the power p. 3 to the power 1 by 3 raised to the power q. 5 to the power 1 by 6 raised to the power r. P plus q plus r is 10 and p, q, r are greater than or equal to 0, less than or equal to 10. Is that okay? This is 2 to the power p by 2, 3 to the power q by 3, and 5 to the power r by 6. Now please understand, if you want this term to become rational, this part is not creating any disturbance. This is the safe part. You don't have to worry about this. No matter what p, q, r is from among this, no matter what p, q, r is from among this, 10 factorial upon p factorial, q factorial, r factorial will always be a rational number. Not a problem at all. Not a problem. Problem will be created by this. You want this part to always be rational. For this part to always be rational, my power of 2, power of 3 and power of 5 should be a whole number, should be a whole number, should be a whole number. Is this making sense? Is this making sense? Each of these powers should be a whole number, right? If each of these powers is a whole number, only then this complete expression will be rational. Only then this complete expression will be rational. So that means p by 2 has to be a whole number, or p can be 0, 2, 4, 6, 8, 10. It can't exceed 10. P will have to be a multiple of 2. A whole number multiple of 2. Q whole number multiple of 3. 0, 3, 6, 9. R whole number multiple of 6. 0, 6. Now, once I know that corresponding to these values of PQR, this term is becoming rational, I can't forget the condition that both these conditions are also attached. I can only choose PQR whose sum is 10. Whose sum is 10. So tell me PQR. If my R is 0, if my R is 0, P plus Q should be 10. So P can be 4, Q can be 6. Anything else? No. P can be 10, Q can be 0 if R is 0. This is also allowed. This is also allowed. Anything else? No. If R is 6, P plus Q should be 4. So P can be 4, Q will be 0. Q 4, no, that can't be 4, P 0, no, that's it. That is it. These are the three terms. These are the three terms. That's it. That's it. Corresponding to these three conditions, these three cases, you get three terms in my expansion which are rational. What are they? What do they look like? 10 factorial upon P factorial Q factorial R factorial, 2 to the power P by 2, 3 to the power Q by 3, 5 to the power R by 6. This is the first term corresponding to the first case. Corresponding to second case, you have 10 factorial upon 10 factorial 0 factorial 0 factorial, P to the power 10 by 2, which is 5, 2 to the power, not P to the power, 2 to the power 5. That's it. This is the second term. And you have 10 factorial upon 4 factorial 0 factorial 6 factorial, 2 to the power 2 and 5 to the power, no, yes, 5 to the power 1. This is your third term corresponding to the third case. These are the three rational terms. You just have to add them and report the sum. These are your three rational terms, guys. Add them, report the sum. Solved it in just one page. The only problem was, generally you are habitual of getting find the rational terms in binomial expansion. This question is talking about multinomial expansion. And you must know the idea. Idea is exactly the same. Only problem is, once you have figured out that P, Q, R should be multiples of 2, 3 and 6, don't forget you have to adhere to both these conditions. P, Q, R can only take values between 0 and 10 and the sum has to compulsorily be equal to 10. After that, we have narrowed it down to these three cases. Just corresponding to these three cases, we've got these three terms. Add them, report your answer. That is what is your answer. Is this making sense, guys? Yes, ma'am, no, ma'am. Is this making sense? Yup. Come then to complex numbers. I will prove to you such an easy question this is. Such an easy question, everybody. Let z bar denote the complex conjugate of a complex number z. I obviously is root over -1. In the set of complex number of distinct roots of this equation. Now, generally you are habitual of cracking this question in the world of reals. Find the number of distinct solutions to this equation in terms of x and y or some other function of real x and real y. Here, you have to find distinct solutions of this equation in terms of z. The biggest mistake which students generally commit in such a question is they try to plug in z as x plus iota y and try to convert it in the world of reals, which is a very natural approach but doesn't work so smoothly and fluently in such a question. You are not supposed to do that. You should not do that. If it's a locus problem, I understand that you are plugging in z as x plus iota y, but in such a question, you should not. Do you have any clue how will you crack it? Huh? Any clue? It's very simple. Just need to focus on this expression for a while and you will be able to crack it. See, you have z bar minus z square equal to iota z bar plus iota z square. Can you see this? So z bar 1 minus iota equal to z square 1 plus iota. Oh. Okay. What next? The trick always which works is now, which is the next step, that is take mod. This is the trick actually to crack this question. This is actually the trick. The trick is to take mod both sides. You get mod of z bar, mod of 1 minus iota, mod of z square, mod of 1 plus iota. What is mod of 1 minus iota? Root 2. What is mod of 1 plus iota? Root 2. Root 2 cancels out. You are left with mod of z bar equal to mod of z square. Mod of z bar is same as mod z and this is mod z whole square. You get mod z whole square minus mod z is 0. This implies mod z common, mod z minus 1 is 0. So you get mod z is 0 or 1. This is the classic type of question which is asked in the paper from complex. The moment you reach this conclusion, you must know what to do. This type of a conclusion, reaching this step and then whatever you have to do forward, you have to do, has been repeated so many times in the paper. Somehow they give you an equation, you have to simplify it, eventually you reach this step. And after this step, what you have to do is something very standard. If you don't know, you are already behind in the race. The moment you get mod z is 0 or 1, after this, the approach is very standard. If mod z is 0, this implies z is 0. So z equals 0 is one of the solutions. But what if mod z is 1? If mod z is 1, this means mod z square is 1. Z bar is mod z square. Z bar is mod z square. What are you saying they are conjugate? Yes, that means z bar is actually 1 upon z. This is what you are getting. So plug it back in your original equation, na? What will you get? 1 upon z minus z square is equals to iota times 1 upon z plus z square. What will you get next? Tell me. Quick. What is this? This is 1 minus z cube is equal to iota times 1 plus z cube. Yes or no? Upon z cancels out. 1 minus z cube equals iota plus iota z cube. So 1 minus iota is z cube times 1 plus iota. You get z cube equal to 1 minus iota upon 1 plus iota. Yes or no? Rationalize? Rationalize, no? What is this? 1 minus 1 plus 2 iota. This is what? 2 upon 2 iota or 1 by iota, which is minus iota. Baba, 1 by iota is minus iota, na? So you are getting z cube equal to minus iota, or z is minus iota to the power 1 by 3. This means just like you compute cube roots of unity, unity is one of the complex numbers, 1 plus 0 iota. Similarly, here you have the complex number minus iota, 0 minus iota, and you want cube roots of minus iota. This will come out to be 3 distinct solutions. I don't know what they are, I don't care what they are. This will come out to be 3 distinct solutions. Is this making sense? This will come out to be 3 distinct solutions. So eventually you have 0 as one of the solutions, 3 solutions from here. So total number of solutions of this question is coming out to be 4. Did you understand? Such a fantastic question, guys. And trust me, it's a very standard category. There is nothing very complexy which has been used in this question. You know what have you done? Just simplified, taken mod, which was the main trick step. Must remember. After that, the moment you reach this stage where mod z is 0 or 1, you know the standard approach. You should know the standard approach. Mod z 0 implies z is 0. If mod z is 1, that means mod z square is 1. So z bar is 1. Z bar is nothing but 1 by z. Plug it back in the original equation and then you solve. You solve, you get z as minus 1 to the power 1 by 3, which has 3 distinct solutions. Is this clear? Very, very, very nice question. Yeah. Very, very nice question. Literally it's a must do and literally it's a must master. If you don't know how to solve this question, you are going to be behind in the race. I'm sorry. Let's come to this one, which is going to blow your mind away. This is the last question of this evening. Last question. After that, I have a couple of questions for you as homework. Last question, guys. Take a look. And this is going to be mind-boggling. Literally. Not in a tough sense, in an interesting sense. It is so interesting. It is so interesting. Very interesting. Let's see. Alpha, beta, gamma, delta, roots of x to the power 4 plus x square plus 1 equals 0. A very famous biquadratic equation. Alpha, beta, gamma, delta are roots of this biquadratic in the first, second, third and fourth quadrant. What is the value of this expression? It's pretty giant expression, but you won't even realize how easily this will be solved. It looks very intimidating, very scary, but very easily this will be solved. Very easily. Do you know how to crack this very famous, very common, highly repeated biquadratic equation? You have x to the power 4 plus x square plus 1 equal to 0. How do you crack this? Huh? X square plus x plus 1 into x square minus x plus 1. Please always, always, always remember this factorization. It's very famous biquadratic equation. It can come in the form of a telescopic series, the general term of a telescopic series, or it can come like this as well in general in algebra, in quadratic, biquadratic, or in terms of complex numbers. Yeah, this is a question of complex numbers. You won't realize the question of complex numbers. It is because now that I have factorized it into two factors, both are quadratic, I know their roots. X square plus x plus 1, what are the roots? Omega and omega square, na? Minus 1 by 2 plus iota times root 3 by 2. This is minus 1 by 2 minus iota times root 3 by 2. So real part is negative, imaginary part is positive. That means this is lying in the second quadrant. Here, real part is negative, imaginary part is negative, lying in the third quadrant. Please tell me if this is clear. In the second quadrant, what I had was beta. This is beta. Let me change the color and show you. This is actually beta and this is actually gamma. If omega and omega square are roots of x square plus x plus 1 equal to 0, then what are the roots of x square minus x plus 1 equal to 0? Minus omega and minus omega square, na baba? How many of you all know this? If x square plus x plus 1 equal to 0 has roots as unreal, omega and omega square. X square minus x plus 1 equal to 0 will have roots as minus omega and minus omega square. That means 1 by 2 minus iota times root 3 by 2. And this is 1 by 2 plus iota times root 3 by 2. This lies in the first quadrant and this positive, this negative, this lies in the fourth quadrant. That means what is this? Fourth quadrant is delta and this is alpha. So alpha, beta, gamma, delta is known to you now. What is alpha? Alpha is minus omega square, everybody. What is beta? Beta is omega. What is gamma? Gamma is omega square. And what is delta? Delta is minus omega. This is the main catch. If you have figured this out, the question is done. It's done. It's done. It's done. It's done. Because you know the four roots of x to the power 4 plus x square plus 1 equal to 0. What are the four roots? You have omega, omega square, minus omega square, right? That means now you can factorize. You can write x to the power 4 plus x square plus 1 as x minus omega square, x plus omega square. In short, what I have written is x minus alpha, x minus beta, x minus gamma and x minus delta. This is what I have written. This is how you factorize. Look at the numerator, everybody. You want 2 minus alpha, 2 minus beta, 2 minus gamma, 2 minus delta. Take x as 2. What will you get? 2 to the power 4 plus 2 square plus 1 is equal to 2 minus alpha, 2 minus beta, 2 minus gamma, 2 minus delta. This is nothing but 21. So one part of your expression is solved. From here to here, this is solved. It's 21. All you now need is the next part, which is mod of beta plus gamma minus alpha minus delta. What do you want? What do you want, guys? You want mod of, see, from here to here it's sorted. This is 21. What do you want? Very good, Naman. You want mod of beta plus gamma minus alpha minus delta. Okay, fine. What is beta? Let's see. Beta is omega. Okay, what is gamma? Gamma is omega square minus alpha. Alpha is minus omega square and minus delta. That means plus omega. 1 plus omega square is 0. So omega plus omega square is minus 1. Again minus 1. The answer is 2. That means this much part is 2. Very good. Very, very good. Now I am left with just the bottom part. Now I am left with just the bottom part. There are two brackets. One bracket is say 1 minus alpha, 1 plus beta, 1 plus gamma and 1 minus delta raised to the power 207. Let's try to solve this. What is alpha? Alpha is minus omega square. So 1 minus alpha means 1 plus omega square. Alright. What is beta? Beta is omega. So 1 plus omega. Alright. What is gamma? Gamma is omega square. So 1 plus omega square. And 1 minus delta. Delta is minus omega. So 1 plus omega. Raised to the power 207. Alright, Baba. What is 1 plus omega square? This is minus omega. 1 plus omega is minus omega square. Again minus omega square raised to the power 207. Now this gives you omega cube and this gives you omega cube raised to the power 207. Omega cube is 1. This is 1. This is also 1. This gives you 1. That means from here to here, this complete value is just 1. Wow. Can you see this? How easily we are able to crack this question. Let's come to the last part. This is alpha to the power 243 plus beta to the power 243 plus gamma to the power 243 plus delta to the power 243. No doubt. Alpha, beta, gamma, delta are what? What is alpha? Alpha is minus omega square to the power 243. Beta is what? Omega to the power 243. Gamma is what? Omega square to the power 243. And delta is what? Minus omega. So minus omega to the power 243. 243 guys is a multiple of 3. And you know omega raised to the power 3k is 1. Because omega is a cube root of unity. So omega raised to the power any multiple of 3 is 1. This gives you 1. Yes or no? Minus 1 to the power 243 will give you minus 1. Yes or no? Minus 1, plus 1, plus 1, minus 1. What do you get? Is it a 0? Or a 4? Is it a 0 or 4? Huh? Multiple of 3. Quickly see what is alpha. Alpha is minus omega square. So minus omega square to the power 243 means minus of omega to the power, omega square to the power 243. What is the answer? Minus of omega square to the power 243. Omega square to the power 243 means omega to the power some multiple of 3 which is 1. So you get a minus 1 or no? You get a minus 1 or no? (21 into 2). Naman, please tell me, how are you getting that? Huh? How? Quick. 21 by 2 is the answer. Will you check this? Will you check this? Is 21 by 2 the answer or not? What do you think? Is it the answer? Yes or no? Guys, respond. Come on. Respond quickly. Now, this is for you to complete. I have left you on a questionable note. This is for you to complete. Come on, tell me. Huh? It is, I guess, correct, but what is the justification? I'll leave this question to you. I have left you on a questionable note and I want you to comment below the answer very, very quickly the moment it occurs to you, the moment it strikes you. But did you understand the question? It was such a wonderful, wonderful question. I told you it's mind-boggling, but not in a sense that you will not understand it. Mind-boggling in the sense of approach. The moment you get this biquadratic equation, very important people to understand how do you break it into the multiplication of two quadratic factors, and very important is to know the roots of both these quadratic equations. It's going to make life super easy for you once you know the roots of these two quadratic equations. X square plus x plus 1, the roots are omega omega square. X square minus x plus 1, the roots are minus omega square. Understood? And accordingly, whatever is lying in the first, second, third, fourth quadrant, you assign them the alpha, beta, gamma, delta terminology, and then you can move ahead. Is it okay? After that, we just broke our expression into 4 parts and we solved each of the 4 parts. Plugged it back, got the answer. Is it cool? Everyone, please tell me, is this clear? Is this clear? Yup. Any doubt, any confusion? Okay, let's attack this as the last question. I told you previous one was the last, but let's make this as the last. It's okay. Let Z1, Z2 be the roots of this quadratic equation, but this time the quadratic is given in terms of Z. Let A and B represent Z1 and Z2 in the complex plane. Angle AOB is theta. OA is equal to OB. O is the origin. What is the value of 4 sine squared theta by 2? Very nice. Very relevant question for JEE Main. 4 sine squared theta by 2. Guys, the problem is, here is your argand plane. Alright, cool. This is your argand plane. Okay. Something like this. This angle is theta. Okay, fine. Okay, fine. Let me make the arrow here. What will you do is, this is your Z1, let's say A, and this is your Z2, let's say B. A and B represent the complex numbers Z1, Z2 in the complex plane, and Z1, Z2 are the roots of this equation. Chalo, cool. And angle AOB is theta. What will you do? What is the relevance of this quadratic equation? Do you understand? See, you have Z square minus root 6Z plus 2 equal to 0, having roots as Z1 and Z2. That means sum of the roots is minus B by A, so it gives you root 6. And product of the roots is C by A. This is exactly what the question is trying to tell you. You don't have to solve this quadratic equation in Z and get the actual roots. No, not interested. Just understand the sum of the roots is root 6, product of the roots is 2. Very important piece of information is given over here. Moreover, here the question, as you can see from the diagram, is based upon rotation. Understand the logic very nicely, because after this you will never forget. I have learned it through this trick once and I have never forgotten. Never ever forgotten. Let's say I want to take Z2 to Z1. I want to take Z2 to Z1. I want to rotate Z2 by an angle theta in the anti-clockwise direction and make the arrow. I want to take Z2, rotate it in anti-clockwise direction by theta measure and take it to Z1. But Z2 and Z1 can have different modulus. Mod Z1 and mod Z2 can be different. Yes or no? It can be different. No, mod Z1 and mod Z2 can be different. So what will we do? The trick is you make each one of them into unimodular complex numbers. So you take Z2, make it unimodular. Then you rotate by an angle theta in anti-clockwise sense and it will match the unimodular Z1. Because both are unimodular. Both are of modulus 1. So once they both are of modulus 1, you take the unimodular Z2, rotate it by theta measure in anti-clockwise sense. It will coincide with the unimodular Z1. How do you write it in mathematics? Z2 upon mod Z2. This is the unimodular Z2. I have made Z2 of modulus 1. When you multiply this with e to the power iota theta, it simply means you are rotating it by theta measure in the anti-clockwise sense. So you have first made Z2 as unimodular, multiplying by the rotation measure. That means multiplying with the quantity e to the power iota theta, which means you are actually rotating this unimodular complex number by theta measured in anti-clockwise sense, and that is giving you the unimodular Z1 complex number. This is what it means. This is your rotation theorem. That's it. That's it. This is what it is. This is what it is. Okay? Okay? This gives you what? Tell me, this gives you Z1 upon Z2, yes? Okay. Z1 upon Z2 is equal to mod Z1 upon mod Z2 e to the power iota theta. Now the question says OA is equal to OB. OA is nothing but mod Z1, OB is nothing but mod Z2. So we didn't have to convert it to unimodular. It's okay, even if we have, these two will get cancelled out because they both are 1. So you are getting Z1 is e to the power iota theta times Z2. This implies Z1 is e to the power iota theta times Z2. This is the third piece of information. So you have 1, 2 and 3. 3 pieces of information. Can you see this? You have 3 pieces of information. How will you move ahead now? That's very simple. Please understand. You have Z1 plus Z2 is root 6. You have Z1 into Z2 as 2 and you have Z1 upon Z2 as e to the power iota theta. This is what you have to use to get the value of 4 sine squared theta by 2. How in the world will you do that? Hi Gaurav, how in the world will you do that? How in the world will you do that? Huh? Any idea? How in the world will you do that? How will you combine these 3 pieces of information to get 4 sine squared theta by 2? Please understand, Z1 plus Z2 equals root 6. Catch hold of this and square both sides. You get Z1 square plus Z2 square plus 2Z1 Z2 is equal to 6. Huh? Yes or no? You get Z1 square plus Z2 square, or rather just divide by Z1 Z2. Let's divide by Z1 Z2. Okay. It's non-zero, na? I can do that. Divide by Z1 Z2. Here also divide by Z1 Z2. What's the problem? This gives you Z1 upon Z2. This gives you Z2 upon Z1. This to chalo cancels out. This gives you 6 upon Z1 Z2 is 2. Which gives you 3. 3 minus 2 is 1. You get Z1 upon Z2 plus Z2 upon Z1 is equal to 1. What is Z1 upon Z2? This is e to the power iota theta plus reciprocal e to the power minus iota theta. E to the power iota theta is cos theta plus iota sine theta. E to the power minus iota theta is cos theta minus iota sine theta. So plus iota sine theta minus iota sine theta cancels out. You're left with 2 cos theta is equal to 1. That means cos theta is 1 by 2. Theta is 60 degrees. Theta by 2 is 30 degrees. So 4 sine squared theta by 2. What is this? Four times sine 30 is 1 by 2 whole square. This gives you 1 as the answer. This gives you 1 as the answer. Such a brilliant question. Such a strong end to today's class here. Brilliant question, guys. Did you like it? Hit the like button then. Don't shy away from hitting the like button if you're liking the session. Such a nice question. Please remember, when you're given this quadratic, you not necessarily always have to get the roots. I am not interested. I just need to extract these 2 pieces of information from here. What is the sum? What is the product of roots? After this, the diagram itself was shouting out loud to use the concept of rotation. In complex numbers, I told you it's very simple. You make the complex number unimodular, make Z2 unimodular, rotate it in anti-clockwise sense by theta measure. It will match, it will coincide with the unimodular Z1. When you rotate by theta measure, means you multiply by e to the power iota theta when theta is being measured in anti-clockwise sense. If you're traveling in clockwise sense, you multiply with e to the power iota minus theta. E to the power minus iota theta. Is it clear? And then we just use these 3 pieces of information which are here to get our answer. So smart, so lovely, so handsome. Such a pretty question, yaar. Must do. Gave me a smile on my face. I hope it gave a smile on your face too. Alrighty, folks. So on this note, it's a wrap. These are your 2 homework questions. Homework question number 1, based upon a very important concept of common terms to form a new AP. And this is another homework question. 2 very, very important homework questions, very, very relevant homework questions based upon concepts which are highly, highly important and relevant for your JEE Main exam. Definitely drop down your answer in the comments below, or you can reach out to me at Study with Bhoomika Ma'am Telegram channel as well. Okay, this is my Telegram address. Is it clear? All right. Don't forget to share the session with as many folks as you can. Don't forget to hit the like button before you leave. And as I said, the questions discussed today were really, really good, rich, high quality level questions. I had clubbed a lot of PYQs to give you one question also. That's also in many questions I've done today. So make sure you are again reviewing the questions, again going through the questions, because this session is literally giving you a polishing of algebra, a good sharpening of concepts, and a final polish, a cherry on the cake when it comes to algebra. So a very rich session, again, vouching for all the questions that I have discussed today, even the 2 homework questions, very important. Please make sure you revisit them. You recall how we had solved them, the concepts involved, the results, the tricks, the hacks, all the time-saving calculation hacks as well. Everything, please revisit again, then only it will be cemented in your memory, in your system. And that's what we want right now. Right now, we want things to be solidified. We don't want them to be on the surface level floating. We want them to deep dive and enter in our system. Right? Okay? So all the very best. If there is any other confusion, any other doubt, please feel free to drop it down in the comments, or you can reach out to me on my Telegram channel. I'm active there. I love to talk with you over there based upon your academic or personal doubts, whatever. So reach out to me there and we're going to have a good chat. Thank you so much. Bye-bye. Take care. It's me, Bhoomika, signing off.